Welcome everyone. We are here to welcome you to NWERC 2020, the late edition. My name is Gunnar and I am the Regional Contest Director for NWERC.
And I'm Bjarki, I'm the Technical Director and Head Judge for NWERC 2020.
We will be your host this weekend and we are hosting it from Reykjavik University. And to start it off, we are going to have a nice little welcome message from our very own Dean of Computer Science, Luca Aceto. Luca, over to you.
Good morning, everyone, and welcome to Reykjavik University. Albeit on a virtual in a virtual setting. As chair of the Department of Computer Science, I have the great pleasure of being with you to sort of pave the way to 2 days of scientific fun that you're having. This is a great pleasure, even at 8 o'clock in the morning on a Saturday, because there's nothing better than being with committed, young, bright computer scientists coming from 12 or 15 different countries, depending on how you count, and representing about 120 teams, competing at the best of their abilities in an activity which is so creative as programming and problem solving using computer science techniques can be. Let me thank all the local organizers, Bjarki August, Gunnar Freyr and their team, for making this possible twice this year. As I said, I'm the chair of the Department of Computer Science, and this is actually the place where Bjarki, August, Gunnar Freyr, and I believe most of their teams have studied or are studying now before sort of going out to the big wide world and making a mark there. This shows that with a computer science degree, the world is your oyster. You can work wherever you want, whenever you want, and make an impact on society at large. The Department of Computer Science that you're virtually visiting at Reykjavik University is the largest and most research active computer science department in Iceland. We offer a number of degrees. We have faculty, postdocs, and PhD students from at least 16 different countries at my latest count, which is one of the things we are proud of. We value diversity because a diversity of opinions and of approaches to problem solving is fundamental to computer science, just about as in any other subject and in life in general. We have about 900 students, including some that will compete with you today. And about 28% of them are women. That's the statistics we are proud of, but it's still way below what we would like to have. So if in the future you're considering further studies to further hone your skills as computer scientists, come to us and you will see a vibrant research and teaching environment with lots of very bright local people, but also people from all over the world. Over the next 2 days, you will, as I said before, compete, hone your skills, and enjoy yourselves. I think the last part might even be the most important part of it all. We live in uncertain times, and prediction about the future is always been difficult, as Pete Dine and Niels Bohr have said repeatedly. But you are some of the most creative minds that we have today. Make no mistake, I mean, when people think about creativity, they think about poets and novelists, artists of any kind. But as Donald could put it, you are artists yourselves, because science is what we understand well enough to be able to teach it to a computer, and art is everything else we do. And this magnum opus is called the art of computer programming. So you're artists as well. And computer science is, as you all know, one of the coolest subjects on earth. And so you're cool. You're just as cool as anyone else out there. In fact, even more so. As I said, prediction is difficult about the future, but as Alan Kay, one of the computer science pioneers who gave us the graphical user interface and one of the earliest object-oriented programming languages, namely Smalltalk, famously put it, the best way to predict the future is to invent it. And now I don't know what the future will be like, but I know for sure that you will invent it. And this weekend will be part of this process that will prepare you to invent a future about which I really don't know very much, simply because it's out there, it's part of a future that doesn't exist today and will be shaped by you. So I will be looking forward to seeing the future that you will invent in the long term. In the short term, I will be hearing, literally, like everyone else in Northwestern Europe over this weekend, the buzzing of your neurons as you create fantastic solutions to challenging problems. So let me wish you a splendid 2 days of work on NWERC 2021. Enjoy it, have fun, and we will enjoy it as well on your behalf. Thank you.
Oh, Mike. Yeah.
Hey everyone, thank you so much for those inspiring words, Luca. We'd like to thank Reykjavik University for all their help in helping us organize this event. Couldn't have done it without you. And speaking of sponsors, we have a few sponsors for this contest. We'd like to thank all of them: Huawei, JetBrains, and AWS Educate. And actually, we will now have some short messages from a couple of them.
Is a journey of doubt and uncertainty. From 5G deployment and its ecosystem came digital transformation in all industries. From Huawei Cloud came the wonders of widespread remote healthcare. From AI machine learning came better, more intelligent ways to protect the Earth. From AI computing came advanced astronomy research and a deeper understanding of the cosmos. From new ways to live, a greener Earth, and futures beyond our imagination. Our journey of innovation will never end.
Hello everybody, I'm Andrei and I work for JetBrains as a Senior Vice President of Investments, Research and Education. Welcome to Regionals. Great things happen when great minds come together. JetBrains wants to seek out great minds all across the globe, support their initiatives, and work together to create great things that will make the world a better place. That's why JetBrains is proud to be a Global Tools sponsor of the ICPC. There are already many great minds working at JetBrains, and together we have created some amazing things, like the Kotlin programming language, for example. It keeps on growing and growing in popularity. In 2017, Google began officially supporting Kotlin as a language for writing Android applications. We have also created professional development tools like Cline for C++ programmers, IntelliJ IDEA for Java, PyCharm for Python, and also educational tools that help people learn and teach programming. The regionals are the biggest contest in the ICPC calendar. Thousands of talented people all over the world team up to solve complex real-world challenges. These contests are the proving ground for future champions. But even if you don't make it through to the finals, the experience of competing in the regionals and the new friends you'll make along the way are priceless. Enjoy the ride. Best of luck to everyone.
Thank you so much to Huawei and JetBrains and AWS Educate for sponsoring this contest. It's great to have good sponsors like them. Now to some numbers. So we have 434 participants this weekend, including contestants and coaches, in 120 teams, 52 universities, in 12 or 15 countries, depending on how you count. And the number of times we had to completely change all our plans was at least 4.
Yeah. It's been a long process.
Yes, yes. But finally we made it, so we are hoping that we can give you a great event. Now, there's a lot of rule changes that happened due to the online nature of the event this year. Some notable ones are, of course, that you can compete from anywhere. You don't have to be here at Reykjavik University. You can compete from anywhere in the world. And most importantly, teams do not have to compete from the same location. You're using your own computer for this event, and you will be allowed to use the internet with only a couple restrictions. You're not allowed to post or publish any information online during the contest. So no posting of your problem set or anything about any problem or asking for help on Stack Overflow. It's not allowed. And to go with that, you're only allowed to use information that was published before they started the contest. So if anyone else publishes a Stack Overflow question, you're not allowed to use whatever response they get. That's illegal. You're allowed to use pre-existing code found on your computer or on the internet. If you take something from the internet, just make sure to mark it with a link to the original source. Then we have a couple more rules. You're allowed to communicate with your own team, of course, and we encourage you to do so using whatever means you want, whether it be Meet, Zoom, Skype, Discord, whatever your preferred communication is. But you're not allowed to communicate with anyone outside your team during the contest. That includes your coach, friends, family, etc. There's no restrictions on software you use during the contest. You're allowed to use any operating system, IDE, or editor, and configure it in any way you want before the contest. If you have any more questions on the rules, you can ask us later, or look at the rules on the NWERC website.
All right. So I'd like to give you a quick introduction to our system. So this year we'll be using Caddis to judge your submissions. Actually, in the background we'll also be using DOM-JUDGE to kind of go over all of your submissions twice to be extra sure of everything. So here on my laptop I have the Caddis interface open, and all of you should have received a link to the Judge site in an email. So when you go to that link, this is the interface that you should see. This is the Caddis interface. Let me zoom in a little bit. And if you aren't familiar with Caddis, you first have to start by logging in. I'm going to be using Team 001 as an example. And so you should have also gotten a username and a password in that email. So here you'll see the scoreboard, which is currently has no submissions, but this is like the list of teams that are competing this year. So in this interface, there are a few interesting things to see here. So when the contest starts in half an hour, you'll see the problems posted inside Caddis. So everything will be available in this interface. You'll have the problem statements and a link to click submit to submit your submissions. I wanted to mention here clarifications. So this will be your main way to communicate with basically everyone outside of your team during the contest. So this is like if you have any technical questions for the organizers, for us, if you have anything you want to clarify about the problem statements, if there's anything unclear in the problem statements or you don't understand, you should basically anything that you want to clarify or anything on your mind, that should be posted to the clarifications interface. So you just ask a question here, choose a topic which could either be general or one of the problems, and just submit your question. So we'll go through these during the contest and try to answer them as soon as we can. And we will either basically reply only to the team that answered it, if it's only relevant to that team. But if it's information that's relevant to all teams, then we'll send out an announcement with our answer. Again, if we'll send out such an announcement, you will see this come up in the Caddis interface. So you keep an eye out on that, and make sure to let your team members know if there's a clarification request that you notice in the interface. So we also have some documentation in here. If you're, for example, using C++, we have basically an example of how you submit a C++ program, how you read input and output in Caddis by using the standard input and standard output. So this is like the practice session is a great time to be testing all of this if you haven't already. Here in the how to submit on this how to submit page, for those that like submitting from the command line, we have here a tool to submit solutions directly from the command line and instructions on how to install it. So this can be very handy. So when you have solved a problem or implemented a solution to one of the problems, you can either click the submit button in the problem itself, or click the submit button here at the top, and you'll be able to either select the file, your source code, or copy paste it directly onto the page, and then hit submit to submit that solution to the judges. So as soon as that happens, you'll be taken to the submission, and in a couple of seconds, maybe a minute at most, you should have received a verdict of the submission. Either accepted, which means that it was accepted, or one of the other verdicts that we have. So I think that's it for the Caddis interface. Maybe one more thing I could point out here is in the settings interface, you can change the default programming language so that you don't have to select it every time you submit a new solution. Okay. I'd also like to point out our website and actually the emails that we've sent to you. So in particular, one of the things that we wanted to make sure that all of you saw is that the judges sent out a document yesterday with some hints and advice about the problems this weekend. So it's here on the NWERC page. And again, I just wanted to make sure that all of you read this before the contest. And in particular, there's new information about the inclusion of interactive problems this year. So make sure you give that a read, and be sure to let us know if you have any questions in the clarifications interface. So I think that's it. We will be answering any questions that we receive during the contest. We'll try to answer them during the contest, but if we don't get to them, we'll answer them later today after the practice session, and might have to come back to you tomorrow morning if there's anything that we can't answer just right away. So I think that's it.
Yeah, maybe one more thing that's good to mention again is that tonight will be daylight savings. So tomorrow the times will probably have shifted for you. So make sure that you arrive on the right time. And we have on the NWERC page website, we have the schedule, and along next to each event in the schedule, you can click the time slot, and you'll be taken to timeanddate.com, which will tell you exactly when in your time zone that the event is. Correct.
So I wanted to say something more. So one thing I wanted to point out is that we are live on YouTube. I think on this side, here to my left, you have the YouTube chat. We kind of wanted to try to make things interactive, so we'd like to get your questions and your any fun comments that you have. Be sure to post them there. For example, everyone could spam the chat now and say, hi, hello, Reykjavik University, something like that. We have some time for questions, so if you'd like to ask us anything before the start of the contest today, this is your time. I will see your questions on my question box here. While we wait for some questions, if there are any.
We have one question already.
Okay.
From Omadak, is the default programming language automatically changed for everyone in a team or just for that user?
Okay, yeah. So all of you share the same account. So each team only has one account on Caddis. And that means that you share the settings as well. So yes, if one of your team members changes the default language to Python, then that will be the default language for all of you, all of the team members of that team. Yes. So you'll have to manage with that,
yeah.
sadly.
And Konstantin Decker, why is it called NWERC 2020 and not 21? That is because this contest was supposed to be held in 2020 in November, and it's part of the 2020 regional events that will give you a chance to advance to the 2021 World Finals. We will have NWERC 2021 happening hopefully this year in November, so you only have 8 months until the next contest, so double hype for that.
Yeah. Yeah, but from the judges, from the jury, and from all of us here, we just kind of wanted to congratulate all of you for being here. It's already quite an achievement to be kind of selected to represent your university at the regionals. So congratulations for being here. You've done a great job already. So Unnur and I are actually past contestants ourselves. We took part, I think last time 5 years ago, in NWERC in Bath.
Well, I competed last time 3 years ago, but
Right,
together
okay.
it was 5 years ago.
Yeah, so I know how exciting this is, how much of a fun event the NWERC is, and how fun it is to solve the problems and so on. So I hope despite this online arrangement, you'll be able to enjoy the contest and the activities that we've arranged around it.
So we have a couple more questions. So from A-Lever, how will I get my prize for winning when I win? Well, if you win, we will send you a prize. If you get first place, you will get this great cup that we have here right beside it. And if you get a medal place, we will send you a medal and maybe some other goodies. We'll see. Another question from Jonas Smith. Are different team members allowed to code at the same time? Yes.
So you have 3 machines. You have each of the team members has a computer. You're all allowed to use the computers at the same time. Yeah, so there's no issue with that.
From Milena, is it possible to get a Domjet sticker? We'll have to talk to the Domjet guys. Nikki, Tobias, if you're in the chat, maybe you can send them. From A-Liver again, will you send my balloons as well?
We can definitely consider that.
Yeah, that's a consideration. Maybe uninflated balloons for all the problems you solve.
We can have a look at that.
Will we still be bringing balloons during the contest? No.
Yeah, sadly not. We thought about making a virtual version of this. Maybe use something digital like a blockchain to deliver your balloons. But sadly, we weren't able to come up with anything.
Any more questions from the chats? No. Anything else you want to add, Bjarki?
No. Don't think there's anything else. Okay, so if there are any more questions, be sure to ask in the clarifications interface during the contest. There's a question about how many problems there will be today. That's classified. I have to, if I tell you. Yeah, that's, we can't disclose that. All right, so take any more questions to the clarifications interface. So I'd like to, so basically we'd like to let you prepare for the session. Make sure that you get logged in and set up like the conferencing with your team and so on. So we'll get out of your way. We have a tradition in ICPC, which is for good luck, to allow teams to touch the cup before the start of the contest. So as kind of a way to send all of you on to the practice session, I'd like to let all of you touch your screens and the cup. All right. That's it for now. So good luck in the practice session. Make sure you have fun, and we'll see you afterwards in the live stream after the contest. That's it.
welcome back. I hope you had a great practice session and that you managed to figure out all your problems and everything went well. Next up is Tech Talk by Andres Le. Andres Le is a Haskell consultant and a co-owner of Well-Typed LLP. He's based in Regensburg, Germany, and he started using Haskell in 1997 when he was an undergraduate student of mathematics in Constance. He's been an enthusiastic functional programmer ever since. He obtained the computer science degree, PhD in computer science from Utrecht University in 2004, where he extended the Haskell language with capabilities for data type generic programming. And he was a university lecturer for several years before he joined Well-Typed in 2010. He's very interested in applying functional programming to real-world problems, and in particular data type generic programming, domain-specific languages, type system, parallel and concurrent programming, and theory of version control. I hope you have a great time listening to him. So over to you, Andres. And one thing to note is that we will be having open questions during the session, so please use the YouTube live chat to ask any questions you would like to our speaker.
All right, thank you. I hope you can hear me, and I hope you can see my screen. So, yeah, I know that. I first of all, I hope that you all had a good practice session, and secondly, I know that I'm talking like in the context of a programming contest, and that in a programming contest, perhaps sometimes you're tempted to adopt a little bit of let's say flexible relationship with correctness, perhaps, in order to like perform well under the time pressure. But one of the things that I'm personally so interested in, or one of the reasons why I'm interested in functional programming in Haskell, is that it is allowing you to, with little effort, write like relatively correct programs, and that you have a strong type system that supports you. And personally, I feel like even more so in a stressful situation when there is little time and I have to get things right, I like to trust the type system. So today I'm going to give this talk on true lies and false truths, so on the importance of evidence and programming, and I'm going to show you something that I find quite important in programming, and I hope you like the idea as well. I'm going to show this in the context of Haskell, but it is applicable to essentially all of programming. It is perhaps not as easy to use in some languages that don't have the necessary concepts, because really, as it turns out, the important things we're going to use are the notion of sum types, or more generally algebraic data types, and pattern matching. So those are the basically two important concepts here. So let's have a look at a simple test. So this, let's just assume you have a function isValidEmail that goes from a string to a bool. So the idea is that you check a piece of text whether it's at least a syntactically valid email address, and then the outcome is either true or false, depending on whether that is the case. And if you have such a test, you can use it in a piece of code that could look roughly like this. So you have some piece of code, and the first thing you're doing is you're reading some untrusted input from somewhere. I mean, it can be a file, can be a database, can be the keyboard of the user or something, and then you get a piece of text, and then you're running your validation function on this piece of text to check whether it's a good email address. And if the outcome of the test is successful, then you go on and do some other stuff with this piece of text. And otherwise, I don't know, perhaps you're like reading more input, or you're printing an error message or something like that. Okay, and then you go on into some other function that takes a piece of string, a string as an input, but you're expecting it to be a syntactically valid email address at this point. And sooner or later, you're actually going to perhaps send an email where it becomes really important that you're using a syntactically valid email address, at least, right? And other things may become important as well. But this is not ideal code, right? Because first of all, at this point, from the perspective of some other function here, we can never truly be sure whether this email address has actually been validated, right? I mean, we're getting a string, and the string could be anything. There is nothing that the type system does to enforce that it is an email address. We could write it down in the comments. Please make sure that you're calling this with a valid email address, right? But nevertheless, there's always a nagging feeling that like, have we validated this? Is it good? And we could do it again, right? So the temptation would be to like compensate for that by like running isValidEmail again right here. But then perhaps we're like scattering lots of redundant validation efforts all over the program text, right? So that's not really ideal either. And if we try to look very carefully, what really the source of this problem is that we have performed this test here and we're getting a Boolean out. And while to us as human readers, perhaps true has a certain meaning and false has a certain meaning, in terms of the type system and what the computer knows and what we can reliably work with, we haven't actually learned anything from the outcome of this test. Because a Boolean is either false or true, and both these values are like qualitatively the same. There are different values, okay, but they have the same type, and they're interchangeable without like breaking the program in the sense that the compiler will reject it, right? So it's very easy to make mistakes. And so forgetting the test here, for example, and just calling some other function on txt immediately would still have the program work in the sense that the compiler will still accept it. Running the test twice will still have the program work. So the conclusion here is that the Boolean is the problem. So Booleans considered harmful in this talk, and I'm going to show ways to like do better. What can we do in order to do better? We want a test which actually allows us to learn something from the outcome, right? And learn something not just as the human user, attaching some meaning to these labels, true or false, but learn something in such a way that the compiler, that the type system of the language can actually work with this. Okay, and the solution here is to provide evidence. Evidence, in this case, of the successful test outcome. So rather than returning a Boolean, we're going to return something of a maybe type. So this is a data type declaration in Haskell that says for every type A, we can form a type maybe of A. And there are two possible shapes of values in the type maybe A. One is called nothing. So nothing is a constant of this type that signals failure. And you can think of it as a new name for false. So that is what we're going to use if a test is negative, right? And just A, so just takes an argument of some type A as and then forms a value of this maybe A type, right? Just signals success, but it takes a value of some type. So this replaces true, but unlike true, it actually carries some piece of evidence. And the idea is that this evidence gives us a handle for like the successful outcome of the test that we can actually rely on. So how does it look? So our old isValidEmail function had the type string to bool, and we're now going to change this type into string to maybe of email. So rather than just saying yes or no to a given string, our function isValidEmail now has like two options still. It can fail the test, and in this case, we will return nothing. Or it can pass the test, and in this case, it will actually transform the input string into a new type, which we call email, and will return just of that transformed email. And now, if we look at the same piece of code, we can still read a piece of input, and we get a string, and we can call our new isValidEmail function on that piece of string. And now we're not using an if then else, but we're using a so-called case expression, where we're saying we want to match on the result of this test. And there are two options. There are still two options. One is that the test failed, which is this nothing case, in which case we are still going to like do something like print an error message or recover from the failure somehow. But in the successful case, we now get access to the transformed piece of text that is the evidence of the successful outcome. And this variable email here has type email now and not string. And we can go on and call some other function on this variable of type email. And then indeed, some other function is now going to take an email rather than a string, which is a new type and a different type. And the good thing is that in here, just by using a different type, we know as the programmer that we have already performed this test, right? We no longer have to wonder, did I run this test or did I not? Just by the fact that I'm getting something that is not of type string, but of type email, I know that well, yeah, I have to have run some validation on it, because presumably there is no other option of actually producing a value of this type than to run a function such as this that actually checks that some input is a valid email address. So here we can no longer forget to run the test, because if we would just call some other function with txt, it would not be type correct. And in here, down here, we can rely on the check having happened because we have something of the evidence type. All right, so let's summarize. Before all this, we had something where the test outcome was a Boolean. And the problem is that to the type system, the two values of a Boolean are completely interchangeable. False and true are, you can interchange them in your program and your program will still type check. So it's very easy to forget a test, and it's very easy to run a test unnecessarily often if you're paranoid and want to overcompensate. Afterwards, we've changed the test outcome to maybe of some new type, where that something is evidence. So the successful outcome of a test now provides evidence. And we have replaced the if then else, which is symmetric, and we can flip both branches and it will still work. We have replaced that with a case of expression, where we have two branches, and only in the case for the successful outcome, we actually get access to this evidence, which we can then use to pass it on to other functions, which can then rely on the fact that we have actually performed the test. Okay. So by the way, I'm quite happy to get questions during the talk, and I'm occasionally going to ask Unar whether any questions have accumulated. So I mean, if that's the case already.
So far there are no questions
okay.
to you.
Okay. That's
just
good.
Keep going, and hopefully you'll get some questions.
Yeah, I mean, by all means. I mean, if you want me to clarify anything, then just ask on the YouTube live stream, and Unar will forward the questions to me. Okay. So so that's that was the first example I wanted to go through, and that is like basically conveying the main idea. But now I want to show a couple additional examples that go into a bit more detail and see that this idea is more widely applicable. And there is one thing that I have been kind of glossing over so far, namely that I have, like, it's relatively clear if you look at isValidEmail of type string to bool, it's relatively clear how you would write this, right? So you would implement some kind of check that would check whether the string is of the right shape, and depending on that you say true or false, right? But now if we introduce a result type like this, then what is this type email? And like, sure, if we implement the function and the check fails, then saying nothing is still very easy. But if we have to provide some kind of evidence, what is this evidence? How does it look like, right? So I haven't said that yet, and that is one missing piece. And I'll get back to that. But I first want to look at a number of other examples. Okay. So let's look at a different example. And so this is perhaps a typical Haskell example, but nevertheless, I mean, so here we have a list of integers, and we want to sum up all the elements of that list. So we compute a single integer out of that. And one way to implement this function in a functional language, if you have some kind of list data type, is if you have a function is empty that takes a list and checks whether it is empty, yes or no. If the list is actually empty, then we return 0 as the sum of integers in that list, because the neutral element of addition is 0, right? So 0 makes sense as the sum of an empty list. And if the list is not empty, then we use the function head to get the first element out of this non-empty list. And we use the function tail to get all the other elements out of the non-empty list. And this function tail returns another but shorter list. And then we can use recursion on the shorter list to sum up all those elements, and finally add the first element on top. And together we'll get the sum of all the integers in the list. Right, and that is a nice recursive definition. And we're assuming here that we have a function is empty that performs a test whether a list is empty. And we're assuming that we have functions head and tail, that if we have a list of elements of some type A gives us the first element of that list. And this function head is assuming that the list is non-empty. And the function tail is assuming also that the list is non-empty and basically drops the first element and gives us the list of all the other elements of that. And again, we have kind of a similar problem as in the first example, right? Because, so for example, what happens if we accidentally flip the two branches in this if then else? If we accidentally write if is empty list, then head list plus some list of tail list else 0, then the compiler will still accept this piece of code, right? Because our is empty test is producing a Boolean. And as I said before, false or true are, as far as the type system is concerned, of the same type. They're completely interchangeable. So flipping the two branches in this case, in this if then else, will not lead to a compile time error. It will lead to a crash. The moment we are starting to actually run this on any kind of list, well, actually it depends. I mean, if we run this, if is empty is implemented correctly and we flip the two cases, and we're running this on a non-empty list, then we're just going to get the wrong result because we're suddenly getting 0. And if we're running this on an empty list, we'll actually get a crash because suddenly we're calling head and tail on an empty list and our program will crash. Now, this is all nice and well as long as we do a lot of testing, but in large programs, right, if you have these kind of things hidden somewhere, like really testing every single code path is often difficult. And also, this is a nice example still because head and tail, the calls of head and tail are relatively close to the actual test, right? But you can envision a different situation where you perform a similar kind of test, like whether a list is empty or not, and then you pass the list on that you have tested for quite a while to other functions, and you're still having this implicit assumption that the list is non-empty, but it's very easy. Perhaps you have like modified the list in between, or you've done some other operations. It's very easy to kind of forget whether we've actually run the test and whether we can actually rely on it. Okay, So that is like a similar situation as we have been in before, and we can try to again apply a similar solution. So again, the idea is that we provide evidence. Now this time I can be a little bit more concrete about what kind of evidence we want to provide, because what is suitable evidence that a list is non-empty? Well, that is exactly if we can give the first element and the rest of the list. That is exactly suitable evidence for a non-empty list. Because if we have the first element explicitly and the rest of the list, we can recover the original list because we have still all the information of the original list. But simply by having the first element, it makes it totally clear that the original list could not have been empty, right? And we would never have been able to obtain that first element if the list had been empty. So this function has a much more informative result type, because again, if the list is empty, we can produce nothing as the result. And if the list is non-empty, we can produce just of a pair of the first element and the rest of the elements. Okay, so and now if we rewrite some list, we again replace the if then else with a case of expression, which performs pattern matching. And in the case that the list is empty, we're now getting nothing rather than false, and we return 0. And in the case that the list is non-empty, we're getting evidence for that. Namely, we get the head and the tail, and this cannot fail, right? Because it's built into the test that we get the evidence that the list is actually non-empty. And so we can safely access, and this actually should not be 1 plus, but it should be head plus. So did I do this wrong in the other one as well? No, sorry. So this should be HD plus some list of TL, sorry. Okay, so you can still make other mistakes, as you can see. It's saving you from one kind of mistake, but you can still make other mistakes. But the good thing here is flipping the cases is now no longer possible, right? If I would write 1 plus or even the correctly HD plus some list TL in the first branch, I would refer to out of scope variables. This would immediately give me a compile time error. I don't even have access to the head and the tail, right? And I no longer am at risk of potentially crashing either, because I'm no longer calling these unsafe, like select the head of a non-empty list or select the tail of a non-empty list function, because I have combined the testing with the fact of learning from the outcome of the test. So if you have seen functional programming languages before, and perhaps even have seen Haskell before, you will know that lists in Haskell are in fact defined as having this kind of structure. So if you look at the Haskell data type definition of a list, well, in Haskell, actually lists are sort of built in and have slightly special syntax, but structurally, lists in Haskell look exactly like this, and you could define them like this if you wanted to. So lists are a parameterized data type of which there are two possible shapes. A list can either be empty, and then you can like give the name of that constructor nil, so that corresponds to sort of our nothing case, right? And the is empty check, or they are non-empty, and in that case you have a first element and you have a rest of the list. This kind of inductive definition is in fact the basic definition of lists in Haskell. And then you can write some list, and again I made unfortunately the same mistake here. You can write some list in exactly the way as before, only that you don't even need to run this is empty check anymore. You can directly pattern match on the two constructors of the list type, but the same principle holds. You combine the test as to which shape the list has with the evidence that the test is successful or has actually had the outcome that you're expecting, because you're only getting access to the head and the tail of the list in the case that the list is actually non-empty. And this more generally shows that these concepts of sum types and pattern matching are quite powerful, and they're often a little bit overlooked. If you look at literature about Haskell or other functional programming languages, you'll find all sorts of things being said about like very fancy, very advanced features of the type system, like even more recent extensions. But actually, this idea that a data type can have multiple different shapes and that you can use pattern matching to distinguish between them, and that the different shapes can have different evidence attached to them, different payloads, and you only get access to the payloads of one particular shape if you're actually in the right branch. Right? This is called pattern matching. This is already quite old and has been in at least in functional programming languages for many, many years. And I think it is often not quite appreciated just how powerful this idea is, and that it is really a substantially better way of defining a function such as SUMList than using the if then else and the Boolean test that we have seen before. Okay, so this is another good point to ask whether there have been any questions at this point. Still not?
Still no questions.
Okay, well, that's good. I mean, I hope that
Either it's very clear or
I'm going to positively assume for the time being that this just means that it's all very clear. So here is yet another example, and so basically, in a way, I could say this example here is sum lists and so on. This is an example for something where Haskell gets it right, because I think most people in Haskell, and also if you look at the libraries that are out there, would write a function such as SUMList using essentially pattern matching rather than using in this first style that I presented here, right? So that that is something where I think basically Haskell already drives you into the right direction. But there are other situations where at least Haskell's base library actually, in my opinion, does not get it right, and it promotes a function that is not ideal. And one such example is filter. So filter is a cool function. It's an example of a higher order function, something you see a lot in functional programming languages. This is a function that is parameterized by another function. So the way to read this type of filter here is, there you have these many arrows, but you can actually look at it as a function taking two arguments. And the first argument of filter is itself a function that is a test that can run on elements of type A and gives you a Boolean result. So, so if you imagine you're ultimately interested in running this on a list of integers, if you have any kind of test on an integer, a function that checks whether an integer is even, or a function that checks whether an integer is 0, or a function that checks whether an integer is between 1000 and 2000, or something like that, or a function that checks whether an integer is prime, right? And if you have a function that that can check that and can give you a false or true result, then you can feed it into filter as the first argument. And then you also give it a list of integers. And then as the outcome, you get another list of integers that contains, well, and that's where the confusion in a way arises, because the name filter doesn't make it entirely clear. It contains the elements that pass the test, or the elements that fail the test, or which ones? So probably one of the two, right? But actually, I think just by like looking at the name filter, it's not terribly clear, and you actually have to look at the documentation, or even better at the implementation, to be entirely sure. So, so we've learned now we are going to use pattern matching on the structure of the list. So we're not going to make that mistake again. So we're going to look whether the list is empty, and if the list is empty, then clearly we're going to produce an empty list again. And if the list is not empty, then we're going to check using this given function f, which takes an element to a Boolean. We check the first element, whether it passes the test. And now we have two options, and we have to check, like, do we keep the element if it passes, or do we keep it if it fails? And the right answer, although there is no really right answer, but what the actual filter function in Haskell does is it keeps the elements that pass the test. So the definition looks something like this. And in the case that f of hd evaluates to true, we go to the then branch, and then we produce a new list that has hd as the first element. So hd is kept because it passed the test, and then we recursively filter the rest of the elements. And if the test fails on the first element, then we do not keep it, and simply we move on to the rest of the list and filter the remaining elements. Okay, but once again, it is like, it would be equally correct even. I mean, in this case, it's really a matter of agreement, right? And even the name doesn't even make it entirely clear to flip the cases, right? And you really have to know, and it's not obvious, and it's very easy to make mistakes. And that's something that I also actually see with people who begin programming Haskell, that they just accidentally flip the notion of filtering because they misunderstood which way around it is being intended. Okay. So again, it would be actually much nicer if we could somehow make that explicit. And again, we can apply the same idea. We can replace the Boolean outcome here with a maybe outcome. So rather than having function filter go from A to bool to list of A to list of A, we now say we are passing in a test that produces evidence of a successful outcome, right? So we have a function that can operate on elements of some type A, and it can either result in nothing, or it can result in just of some possibly changed type, which provides evidence for the outcome of for the successful outcome of the test. And then our function also goes from a list of A to a potentially different list of type B now. Now, if you have type variables and type signatures like this in Haskell, right, and it means it's a polymorphic function, it can be used at different types, and you're still allowed to use the same. You're still allowed to use the same type when calling the function. You can still say, I have a function that goes from int to maybe int, and then I feed it a list of integers, and I get a list of integers. That's fine. But you can also say, I'm taking something like my is valid email, my better is valid email check, right? And I pass in a list that goes from a function that goes from string to maybe email, right? And then I feed it a list of strings, and I'm getting back a list of emails. And that is better, right? Because if I'm getting back a list of emails from a list of strings, I'm actually immediately seeing that I've actually achieved something, right? That I've made progress. And it's not just me again, not just the human that is seeing it. It's also the computer in the form of the type system, and it can help you along to use this in the right way. So let's apply this, right? So let's have a concrete filtering. Let's see, look at a concrete situation where we might want to filter. So so I already gave one example. One easy example is to check whether a number is even. So a classic check for whether a number is even would probably be implemented in terms of sort of a modulo function on integer division and getting the rest of an integer division. So if we have a mod function, which we have in Haskell, and we call mod I2, we want that to be 0. And this is an equality test. So and the equality test returns a Boolean. So this would be a classic check that something is even that returns a Boolean. And then if we call filter evens, and we check whether, like, we want to know in a list of integer, we want to keep all the even numbers in that list, we can just call filter with the even function on a list. But as I said, I mean, like, we have to know, like, does it keep the even numbers or does it drop the even numbers? And the type does not change. We start with a list of integers, we end up with a list of integers. So again, this is not ideal, right? And we could also easily add a non-even integer again into that list afterwards, because there is nothing in the type system that enforces this list to contain only even numbers. So what's suitable evidence for a number being even? Well, actually, we can use an integer, but a different integer as evidence. So we can, like, define a data type even that has just one shape and that only is intended to capture even numbers, but we just store the integer divided by 2, which must be possible without any reminder if the original number was even. So I've called this constructor here, or this shape, I've called this twice, because the idea is that if we have the value twice 4, for example, then it actually represents the even number 8, right? And if we have the value twice 21, then it represents the even number 42. And we couldn't represent an odd number if the idea is that whatever is in there is representing twice the number that is stored in there. And then we can write the even check to provide evidence like this by saying we go from int to maybe even, and we perform, this is a sort of a function, a variant of the function mod that I showed before, that performs an integer division and gives us back a pair of both the integer part of the division result and the remainder. So if the division by 2 actually succeeds without a remainder, then we know we do have an even number, and we can produce just of twice j, right? And otherwise, we know we don't have an even number, and then we produce nothing. And now, if we look at examples, if we perform an even check on 42, we get just of twice 21, and if we do an even check on 17, we get nothing, right? And now if we revisit the function filter evens, it still works as before, but it actually goes from a list of int to a list of even, and we can see on the type level again that we have actually successfully performed this check. And not only does that mean that we don't have to perform this check again, it also means that it's now no longer easily possible to just add an odd number to this list of even numbers, because then the compiler will also complain. Then I have to explicitly transform this list back into something that is more relaxed again, and then that is tracked in the type system as well. So these are really simple means of guiding ourselves, always just carefully nudging us into the right direction, and just cutting off lots of paths in the program that would lead to unnecessary errors. Okay.
Maybe a question from myself.
Yes. Yeah.
So this seems like maybe to some unnecessarily complicated for something so simple as checking or making sure that you have an even numbers. Do you have any examples of real life use cases where this actually starts making sense to use, where it helps, even though it makes it more complicated?
The first example is a very, very real life use case, right? And so if you and in general, that is really the real. I mean, thank you for the question. I mean, but that is really the real life use case where it matters in virtually all programs, right? that are interactive at all. You're at some point you're reading untrusted user input. You're reading some stuff from files. You're reading some stuff via the internet. You're reading some things from the database and so forth. And you don't necessarily, I mean, even the database, you don't know. I mean, sometimes things have been checked there, but you don't necessarily know that these are all like pre-checked and trusted data. Okay, so you have a part of your program that has to deal with the fact that data is untrusted and unchecked, and this can come in many forms. So an email address is just one simple example, but it can be it can be all sorts. I mean, you like if you have any kind of database that you want to store. So say you have a programming contest task description, right? And you have a data type for that. And a programming contest task description is supposed to fulfill certain invariants. I don't know which ones exactly, but perhaps we have certain requirements. There should be at least 3 tasks and at most 10, and then they should have a sufficiently long description. And I don't know, the description should perhaps like only contain certain characters and not certain others. And then perhaps there are some other constraints on this type as well, right? So you, at some point, when you have some external description format where you perhaps like make your task description available as a text file, or you submit it to a REST service as a JSON document, at some point you will perform additional validation on that input and say, like, does this fulfill all the invariants that I'm ultimately expecting for this piece of information to hold? And it is good if that boundary is clear, right? It is very, very bad if you are performing a check that is ultimately just giving you a Boolean. Because again, this is exactly the point that I'm making. This check then is not just easy to forget, but it also means that in all the other parts of your program, you have to always have this nagging worry, like, okay, I'm making these assumptions now, but can I really make these assumptions? And you're perhaps modifying, like your program is perhaps modifying these task descriptions as you go, right? And you would like to know that like the invariants are still adhered to, and sometimes you may need to recheck. So just by changing such a validation step from having a Boolean result to something that goes explicitly from some untrusted task description data type to maybe of a trusted task description data type, that makes it very clear where, like, whether you've run the check and how often you've run the check, and if you do anything that could possibly violate the invariant, you probably get out of that data type again, and then it's also very clear that you actually have to rerun the check. So this happens all over the place, right? And yet another example is like where you're perhaps not even dealing with exclusively untrusted user input, but still often you're doing some form of templating of say database queries or of HTML documents, right, where you are piecing together HTML pages from various individual pieces, and you have to perform some amount of validation that you have properly escaped all the critical characters in your string, and so on and so forth. And for SQL queries is even more important, right? So that you don't have some sort of expose yourself to some sort of injection attacks. And again, it's very, very helpful if all these transitions go along with type system transitions, where you're actually providing evidence of your transformation, so that you have a different data type for HTML documents, a different data type for SQL queries, that these are not just strings, and that you're guarding the boundaries with checks that actually provide evidence of the successful outcome. I think that that's sort of the real life transfer of everything that I'm talking about. And sure, I've been deliberately going from like a real life example first to smaller examples now to ideally drive the idea of providing evidence home in a simple setting where it's easy, where it's hopefully easy to understand what's going on, even though you may be right. I mean, in practice, you wouldn't do it for every single test, like for just checking whether numbers in a list are even. I would probably not do it myself either. It depends a little bit on how critical this is. But for real like important data types in your domain that you're implementing, I would absolutely do it, and I would do it nearly every time. Okay.
Right. So it's a type of sanitation for your data that can be verified at any single point in the program, rather than you specifically, like explicitly having to sanitize the data at every step. It's just, it happens naturally with...
It happens naturally at a clearly defined boundary, because the boundary is now visible, right? You can see by looking at the type signature of every single function, am I operating on untrusted input or am I operating on trusted input? And it's not just something that you put in the comments as an informal prerequisite. I'm expecting this and this and this additional condition to hold. You're making it visible in such a way that the type system can track it for you and can check it for you. And that's the idea. I mean, in general, type systems are your friend, right? I mean, so this is like one of my general messages as well. I mean, like modern type systems and programming languages are so immensely powerful. You should stop seeing them as just sort of this guardian that stands between you and success, that you have to fight and bash the compiler long enough to finally accept your program. You should really see them as an assistant in helping you, and this is one way of like making constructive use of a type system, because you're saying like, track for me whether I have done this check, right? Warn me if I haven't, whereas otherwise you would have to keep track of it yourself.
Great, thank you. I think that was a great answer. There's another question. Do you want to...
Just let me just briefly say, I mean, we started a bit late. Can we also end a bit late, or do I really have just 7 minutes left? I mean,
no, that's fine.
Okay, yeah, then just go ahead. Yeah, I'm happy.
It's from Ragnar. He asks if you see applications for this return of proof in imperative languages, and if we wanted to, we could do the same in C++, although it would be an uncommon pattern.
So I think really it would be, I think it's great to have this in every languages, but I mean, the idea applies to every language, right? Or the underlying problem applies to every language, that Booleans are just not dramatically expressive. But what you can do about it depends a little bit on what features you have in your programming language. And to make it convenient, right, I think you really need two language features. You need some types. You need to some types basically means you need the way that in a data type you can have different shapes and say this data type is either of this shape or of that shape, and like the different shapes can have different arguments attached to them. And then you need which basically goes along with that. You need a construct which can match on these different shapes all in one go, essentially as some sort of atomic dispatch to like which of the different alternatives something has been built by. And you can see that this is not something that you can only have in like purely functional languages, because so I mean Haskell and standard ML and OCaml, they all have this, but Scala has this as well in the form of case classes, and Scala is in a way a hybrid functional object-oriented language. Rust has this as well, which is not a functional language at all, even though like many functional programmers are like happy to use it because it like takes so many hints from recent programming language theory in its design. But Rust is certainly not a functional programming language, and it has all these features, so you can directly employ it in Rust. And I must say, I'm not totally familiar with all the other reasons. I mean, so for example, I have heard that Kotlin has some form of sum types, but I've also heard that it is basically cheating. I don't know. I mean, this is something where I haven't looked at in enough detail. And I'm sure in C++, which is a language which like has loads of features, you can encode stuff like this as well. The question is, does it become convenient enough, and does it become foolproof enough to ultimately really help you, or will it just replace one one way of making accidental mistakes with another way of making accidental mistakes. That's something I can currently not judge because I just don't have enough active experience with C++. But in principle, the problem is universal to programming in general. And I think programming languages are adopting some types and pattern matching more and more, among other things, for exactly this reason. Right. Okay, so yes, so okay, we were here actually. So so far we've only seen tests that were sort of like providing evidence of a successful outcome. But let me, like, if you bear with me sticking with this toy example for a bit, you can actually provide evidence of failure as well. And sometimes you actually want to not make such an asymmetric decision, but you really want to classify something into multiple, perhaps not even just two, but into multiple different options. And for each of them, you would like to have evidence of that particular option was actually the one that did occur. And this even example does actually allow us to show this, because like every number that isn't even is odd, and we can provide evidence for that as well by making yet again a different type, odd, that we use a number, again an integer, as evidence, but in such a way that 2 times that integer plus 1 represents the original number. So if we had 5 and we would call parity on 5, we would get a value of this odd type containing a 2, because 2 times 2 plus 1 is 5. And then we can rewrite our even function into a more general parity function that actually makes a decision between whether a number is even or odd. Right? So now we don't even just have a maybe type where we have, in the case of failure, we're still just saying nothing, but we're saying either it is an even number or it is an odd number. In both cases, we have evidence for whether the test succeeded or whether the test failed. And here we are now making a distinction as to whether the remainder is 0 or 1. And if it is 0, then we produce a left that is one of the 2 shapes of the either type, where we say twice j. And if we have this result here of the diff mod, then we say right, so that explicitly says that we want to produce an odd number, and then we use this twice plus 1 shape with j again. And the either data type in Haskell looks like this. It really gives us 2 options that are called left and right, and now they both carry evidence, and they carry evidence of potentially different types that that represent exactly the information that is needed in order to prove that that a test was successful, right? Or not successful, but that the test had the outcome that we claim it has, right? I mean, now it's no longer just about it being successful. And again, there is a function in the Haskell libraries that is kind of suboptimal, like similar to filter. By the way, the revised filter function that we had been defining is actually in the Haskell libraries as well, if you know where to look. And it's called map maybe, but it is much harder to find. Partition also exists very prominently in the library, and it has an A to bool, and it gives you 2 lists back, a pair of 2 lists. And again, you have to know which one is which. So actually, like the first one, I think I have to say right now, is the one of all the elements that satisfy this test, and the second one is the one of all the elements that fail the test. Okay, but better would be if we had a partition function that would go from A to either B, C, where we say, like, okay, we actually make a binary choice, and we either provide evidence of one outcome of type B, or we provide evidence of another outcome of type C. And now it would be completely clear from the results are, because it is a list B and then a list C, which one is which, right? Sorry. Okay, so now to get to the end, let's revisit the beginning. And obviously, I mean, in a real program, we're most interested in real examples. And as I said, I think there are really many of these kinds of examples in real code where you perform some checking, some kind of validation on some kind of value, and you have the opportunity to provide evidence. But often the checks you're performing are far more complicated. And we have now seen, okay, sure, for a non-empty list to say suitable evidence is to store the first element of the list and the rest of the list. That is kind of obvious, perhaps. And for an even number to say, okay, we store the number divided by 2, that is still kind of obvious. But what would be suitable evidence for a complex textual check as to whether something is a valid email address? Do we actually like sort of parse this and store an abstract syntax tree? Well, okay, that would be one option, but you can imagine yet more complicated things, and sometimes that may just not be what you want, and sometimes it may actually introduce performance overheads that you don't want, because an abstract syntax tree perhaps has a less compact representation, and you don't really need all that complexity, or you don't really want all that complexity in your program just for a little bit of extra correctness checking. So and perhaps the test is even more complicated, and it is just not obvious what the evidence is. So what is suitable evidence for a complex validation? Now, the good thing here is that the answer is actually surprisingly easy. You don't really need to make a very strong distinction here. You already get all the benefits, essentially, if you are taking a completely pragmatic and lightweight approach at that point, by simply saying, we're going to say an email is still a string internally, and it is still actually the actual string corresponding to the email address, but we are wrapping it up in a new data type, and we are making that data type abstract, and we're guarding its interface, right? And so that has essentially all the advantages that we need. If we needed, an email is isomorphic to the string type, so we can, for example, easily turn an email into a string again by just extracting its contents, right? But we have full control over the interface of email. Email is treated as a different type by the type system from string. We have to explicitly coerce, and we can hide the coercion function. So we can say, even though make email is a constructor that allows us to take a string to an email, we simply don't make that available to the general public. The only function we do make available to the general public is valid email, which performs the check. And then we still have the responsibility to implement this one check correctly, but that's something that we ought to do anyway, and it is relatively clear where the risk now lies. And if we have a clear, controlled interface to such an otherwise abstract data type, then it basically serves all the purposes that we want, right? We can say, if we have an email address, we know it must have been obtained by running isValidEmail on it. There is no other way to even have obtained it. We can rely on that check to have run if we get a value of this type. And we have a limited amount of operations that we can do on it. So we cannot just concatenate 2 email addresses, for example, just because we can concatenate 2 strings, because email addresses are an abstract data type. So there is still no danger of forgetting the test. There is still no danger of duplicating the test. And we don't need to actually be extremely creative in coming up with actual evidence. This sort of lightweight approach is actually enough. Okay. So I'm coming to the end of my talk. So how to win? So how to improve your programming? Whenever possible, replace Booleans with types that actually carry evidence, right? So maybe types, some types of any sort, either types, whatever. And then introduce new types for values that have passed tests, even like in the case of email, if their internal representation does not actually change. Wrap them up in something new. Make them abstract, guard their interfaces, make it clear that you cannot cheat. That I mean, cheating within limits here by choosing the same internal representation, but then like make the interface of that type really limited, so that there is just the only option of obtaining these types and maintaining these types and combining these types are operations that you have carefully checked to maintain the invariance. Okay, and generally avoid functions that have implicit assumptions about their inputs, where you say, I take a string, but I expect the string to be of this and this shape. And then you don't know whether the caller has actually respected this or not. And where you don't know whether you have to run a test again, or whether you can just assume that the test has already been run. And avoid unclear boundaries between untrusted and trusted values, and avoid situations where just flipping around a couple of cases in your program would still make the type checker go, yeah, okay, right, we can try this, right? Always, if you see this, that this sort of stuff is like that, you make a really tricky consideration. Is it this one or that one? And they're actually both of the same type, then there's already a signal that something is wrong with your code and you can do better. And if you follow this advice, then you generally avoid these things automatically. Okay, so as like credits, let's just say that this is not my idea, of course. I mean, the idea goes back, I think, very, very long ago, but it is coming up under different names and is promoted every once in a while again. I personally really learned it. I learned it in the sense that it was really driven home to me by Conor McBride, and I think around the year of 2005, briefly after my PhD, under the slogan "Learning by Testing." So learning, like if you perform a test, you don't want to get a Boolean outcome. You want to get evidence. You want to learn something from it. Bob Harper, programming languages researcher, wrote a famous blog post titled Boolean blindness, right? So that was in 2011. So that is a slightly different term again, but the idea is, again, like Booleans are just not particularly expressive. If you have a Boolean, you're kind of blind to what's really going on, at least the machine is. And Alexis King wrote just recently in 2019, wrote another rather influential blog post that's called Powers Don't Validate, where she's saying validation is essentially this process of making a Boolean check. Parsing is like by producing an abstract syntax tree, but if you look at parsing in the wider sense as just something that takes an unstructured input and provides some evidence, that is the thing that you really want in most cases. Okay. I have one bonus slide, but I think I'm basically out of time, or we should come to an end. I just want to say, if you go to dependently typed languages, and in dependently typed languages, you can mix terms and types, you can provide even far more interesting evidence. So, for example, if you look at an equality test in a normal programming language, that will give you a Boolean result, and it will say, I'm looking at two values of some type A, possibly with some constraints, right? So I mean, perhaps not for an arbitrary A, and it will ultimately give you a Boolean. It will just say, yes, these two values are equal, or no. But wouldn't it be nice if we actually had a proof after performing this test that that the two values are equal, and that we had a proof that the two values are non-equal if the test fails? And in a dependently typed language, you can actually write something like that. And dependently typed languages are up and coming. I don't think they are quite production ready for industrial use, but they're certainly being researched on, and you can do very interesting things with them. And languages that fall in this category are Acta and Idris and Coq and Lean, which are also like primarily intended to be theorem provers or proof assistants, but the distinction blurs a little bit in this area. And this is a fascinating area of languages where you can like do really nice things with this sort of approach and drive it even further. Okay, that concludes my talk. Are there more right now?
Yeah, there's a couple of questions. One general question is, do you see evidence-based programming as one aspect of explainability in computer science, artificial intelligence, etc.?
I can't say that I'm really an expert in artificial intelligence, but I do think that one of the big challenges in artificial intelligence is indeed that we want AI algorithms to like get away from just saying yes or no, right? Or even to just say that this image shows a cat and this image shows a car, but to actually give reasons as well and provide evidence as well, so that we can like check why they've actually come up with the conclusion and how far we can trust it. And I think that in that sense, there is certainly scope for this there as well. I just think because of the nature that AI algorithms work, you'll need to do completely different things to actually come up with that evidence. But it's certainly a good idea in general and in that area as well. Yeah.
Yeah, and one follow-up question to that is if you see any connection to proof carrying codes.
Yes, that is a very direct connection. So the idea of proof carrying code is indeed that I think in the widest sense in compilers, but even compilers, I mean, essentially compilers are programs that translate one language into another, but almost every program translates one language into another. For example, a web browser, right, translates HTML and CSS and JavaScript into some rendering instructions for a rendering engine. So a web browser is a compiler. So I mean, so like lots of things are compilers. And the idea of proof carrying code is that like whatever target language, which can be domain specific and everything you're producing is carrying some additional proofs about its correctness, relating it back to its input, and also justifying its own internal consistency. And that is very much in line, like as essentially just a different viewpoint of what I've just said. Yeah, I mean, and again, I don't think it's sort of totally black and white. You cannot say you have to do this everywhere all the time, and you have to like apply a certain amount of pragmatism as to how far you usually want to push it. But so the point that I'm making in my talk is primarily actually a relatively pragmatic one, that you really can get a big payback for relatively little effort if you just are disciplined about like guarding the boundaries of your application code. Proof carrying code, like the research community, is typically a much more serious approach in the sense that you want to have like full reliability and actually want to be able to reconstruct everything under any price. So the emphasis there is probably slightly different, but the basic idea is very much the same. Yeah.
Cool, thank you so much. I at least learned a lot from his talk. I hope everyone else did as well.
Yeah, I hope you all have a successful contest. Tomorrow is the real run, right?
Correct.
Yeah. I wish you all the best for it, and I hope that the organization goes well as well, but also the participants, that you all have lots of fun and manage to have good results. And who knows, perhaps you managed to avoid a hard to debug bug in the last 10 minutes by applying at least this technique. I don't think you are allowed to use Haskell, but you can still try to apply the idea.
Correct. The ICPC does not allow Haskell, but actually, as I pointed out to someone in chat earlier, if they want to hone their Haskell skills, we will actually host a public version of the contest next weekend, which will be hosted on OpenCatis. And OpenCatis allows Haskell as one of the programming languages, so you can redo all of your solutions again in Haskell if you feel like it's a perfect opportunity.
That's a great, initiative, and I think in general, I mean, like, I think like learning new programming doesn't have to be Haskell, but just trying out new languages is always widening your skill set and also giving you new viewpoints on old problems. So that is always worth doing. Yeah.
All right. Okay. Thank you so much.
All right.
Feel free to watch the live stream tomorrow, see how the competitors do, And even join another competition yourself if you feel like it next weekend.
Yeah, possibly.
Thank you so much.
We'll see. I have been participating in the ICFP programming contest a number of years, so that but not so much in others. But yeah. Okay. Thanks again.
Yeah.
Bye for now.
Bye bye.
There are parts of our world where light can't reach. Divides that are too wide for rivers to flow. But technology has the power to help. In remote areas of Nigeria, connectivity brings new life to local communities, opening doors to trade, banking, better education, and healthcare. In Bangladesh, digital training has given more than 240,000 women new opportunities in life. With AI, deaf children everywhere can translate written words into sign language. So no child misses out on the joy of storytelling. In Central America, upcycled smartphones help rangers detect poachers and loggers, keeping rainforests safe for everyone. Our planet may not be perfect, but digital technology can help make it better. In the next 5 years, we want to work together with our partners to help 500 million more people directly benefit from digital technology. Focusing on healthcare, education, environmental protection, and economic equality. Tech for all. Pass it on.
Okay, are you ready, Jeroen? All right. So next up is our presentation of the practice solutions. So we on the jury are going to go through the practice problems and describe the solutions, and then we'll also go through clarification requests that were answered during the practice session, and do a small Q&A session. So first up is problem A.
Okay, so those that have participated in NWERC in the past may kind of recognize the story. Last year there was a circus tent that needed some surroundings. This year it's a dangerous gas cloud. But the gas cloud has this circular shape, and we know the area, and we are asked the perimeter. Before explaining the solution, I can point you towards the top of the slides. There we have this nice figure showing the submissions over time. So from the start to the end of the practice session, you see the submissions. The green bars are the correct ones, and the other colors at the bottom are the incorrect solutions. So the big green blob at the beginning suggests that most people actually solve this. So it's some mathematics. We know that the area of a circle with radius r is given by pi times r squared, and that the perimeter of such circle is 2 times pi times r. And if you don't know this, then actually in this contest this year you could even Google this up. I'm sure that there are sources on the internet that explain this. And then you rewrite the formulas a bit to compute the given answer, which could be written as one of these solutions. So the square root of 4 times pi times the input. There are some things that you could do wrong here. So one thing is that you should make sure to print enough digits after the decimal separator. So printed with high precision. Here are some examples of how to do this in your favorite programming language. And the input could get quite big. So if you try to read in the input in a 32-bit integer, unfortunately that would not fit. So you should use a big enough data type for reading the inputs. And we got 120 true submissions and 106 accepted. And I think there were also 106 teams that submitted anything in this practice session, meaning that everyone that participated in practice solved this problem.
Cool. I also just wanted to mention that if you have any questions at home, please do add your questions to the chat, and we can try to address them even during the slides. But okay, so next problem is problem B, broken gearbox. So in this problem, you have a set of gears of different sizes, and then a set of spindles that don't have gears on them yet. You want all of them to mesh in a certain way, and this is represented as a graph. So each spindle is represented as a node, and an edge between two nodes means that these two spindles, when they have gears on them, these two gears should touch. And the way that they should touch is given by the length of the edge. So if so the length of the edge basically means that the sum of the radii of these two gears should be the same as this length. So you're asked to find an assignment of gears to spindles such that all of these constraints are satisfied. So what we can do is we can choose an arbitrary root node n, and let's denote the size of the gear on this node by x. So if there's a node m that's adjacent to this root node n, and the edge between these two nodes has a weight of w and m, then the size of the gear on node m must be the weight of nm, like the distance between those two nodes, minus x. That's the only way the sum of these two gear sizes can equal the distance between these two nodes. Now, if we continue like this, we can see that nodes that are adjacent to m must also satisfy a similar constraint. We can kind of propagate this reasoning forward. So the adjacent vertices that are adjacent to m have to have weight WMO, where MO is the weight from m to this adjacent node, minus the weight of nm plus x, because that was the weight that we computed for m, and so on. So as soon as we fix the value of x in a single node, in this root node, we can kind of propagate this forward through all of the graph. And we can notice that when we've done this, all of the vertices will have a weight that is some constant, and then either plus or minus this original x that we chose. So if we have a specific value of x, we can use this algorithm to basically propagate values and find the gear sizes of all the vertices in linear time. But however, there are up to n different possible values of x that we might have to try, because we have n different gears in the worst case. So doing it this way is too slow. We need some better way of choosing which values of x to try. So a key observation here is that if we consider the largest gear, the size of the largest gear, then it has to correspond to the node that has the highest value of this constant plus or minus x. So this could either be a node with a constant plus x or a constant minus x, because in the latter case, the constant might just be that big that subtracting a small x might actually still make it the smallest gear or largest vertex, I mean. So we can't be sure which is higher, so we'll have to check both. Now, if we plug in these two possible values of x, and then use our algorithm to generate the values for all of the other nodes, then we can basically check all of the constraints and see if this assignment works. So the two constraints that we have to check is, first of all, that we have the right quantity of each size of gear. And the other is that every edge constraint is satisfied. There are, however, some gotchas. So when you have, for example, an odd cycle or some weird assignment of weights to edges, you might end up with some inconsistencies in the graph and in the formulas that you kind of derive with the algorithm. So just using these formulae or just using this propagation algorithm to generate these sizes of gears, but only use these formulas to check for correctness, that won't always work. So you have to make sure that you not only run the algorithm to generate the values, but you also go through the whole graph, checking every edge to make sure that every constraint is satisfied. Okay. There's a question about this. All right, so we had 80 submissions, 26 of which were accepted before the last half an hour, which was frozen. We had a problem, or we had a question about this problem. I'm sure I've seen or solved this problem before, and has it appeared in a previous NWERC? And the answer is yes. I think this was from NWERC 2017 practice session there. So other questions? Right. So someone asked about connectivity of the graph. Yeah, things will probably get a bit messier if you have disconnected or multiple components in the graph. But it was guaranteed in this problem that the graph was connected, which means that a single value of x or single node that you guess the value for can kind of infer the values of all the other nodes. Okay, I think we're ready for the next problem, problem C.
Okay, so problem C was an interactive problem to get you into working with in interactive problems a bit. So we can already say that there will be at least one interactive problem in the real contest as well. And in this case, you had to guess or find a 4-letter password, and you could do at most 50 guesses, and the system would be very friendly in reporting back in what you did incorrectly. So I guess the password system was very and was maybe built by some Haskell developer. Maybe Andres built this because instead of just reporting failure as a Boolean, the failure was reported as 2 integers. One is the number of letters that were actually correct, so in the correct position in the password, and the other number is letters that were used in the password but were in the wrong position. And this is also a little game that you can do with pen and paper, but in this case you had the right code to solve it. So here is a possible solution. So first we do 26 guesses. For each letter we just do 4 times that letter. And then we know which 4 letters are actually in the password, because if a letter appears in the password with this guess, it will by definition be also in the right position. So for B, like the number of letters that are in the password but in the wrong position, that will never happen with these guesses. And for A, you just know how often each letter appears. So in total, you will get 4 times, or the sum of all these A values will be 4. So you know which 4 letters to use. And for these 4 letters, there's 4 faculty possible orders. So 24 possible orders, or maybe less if there's duplicates, but at most 24. And you can just then guess all of these. So you do 26 plus 24 guesses, and that's exactly 50. So that's within bounds. And that's should have been enough to solve this problem. But of course, oh wait, yeah, there's some things you couldn't do wrong. You can also solve this problem in Haskell. Actually, you were not allowed to submit that, but if you would do it in this way, then here's a nice Haskell solution. So there's some stuff that you can do wrong here. First of all, you should flush the output. So if you write to the output but don't flush it, you may get time limit exceeded error. We should also we have also specified this in the hints document, but just to remember that you should do this in an interactive problem. A more common mistake actually that we saw during the tests was that you can also guess right in this first part where we say we try all 26 different possibilities, but maybe if the password is AAAA, you actually guess right directly, and then your code should exit cleanly. You should not then still try B and so on. And there was some, or maybe 2 teams that had some problems with the local testing tool. So what we can say is that we can guarantee that if you have a correct solution, the testing tool will locally also say that it's correct. If your code crashes, exit early, maybe prints a wrong answer, it could happen that the testing tool is crashing as well, or not so user-friendly. We have tried to make it as user-friendly and as correct as possible, but it's very likely, if this happens during the contest, means you are doing something wrong in your solution. But we hope that it usually does what the server as well does. There's also an alternative solution. So you can make a list of all possible passwords. So you have 4 times you pick one of the 26 characters. So that's like 400,000 possible passwords. And we just guess a random one. So we have that full list and we pick a random one and we put that in as a guess. Then we get some information back. So we can filter the list, because with the information you got, you can actually decide which of the passwords could still be it. And you repeat this until you guess correctly. And this in practice will likely use way less than 50 guesses. So we had 220 submissions in total and 82 accepted for this problem before the freeze. So let me see if there's any questions on this problem. Does the testing tool return in some way whether the program would be accepted or not? Yes, the testing tool should print if your solution is accepted.
Wait. No, we have to clarify that if your solution pass, like the testing tool is kind of just a way to kind of help you test things locally. If the testing tool, works locally, you get it approves your solution locally. That still doesn't guarantee that your submission will be accepted when you submit it. So it only runs a single test case or 2 locally for you to kind of test your solution locally. Yeah.
Right, and this is something we wanted to share. So an interesting submission that we got for this problem was 685 lines long. So we tried to put it on the slides, but it didn't fit.
Right, so clarifications. There's one more remark in the chat that we might address. So so we had in the slides for the previous problem, we mentioned that you can use and, or in C++ you can use NL to flush your output. But actually, if you use an explicit \n new line character, that actually doesn't flush your output in C++. So make sure you use and, like the NL symbol to flush your output. Okay, so on to some clarifications that we got during the contest that we think are worth addressing here. So we got a lot of questions about whether clarifications could be written in languages other than English, and the answer is no. Please ask your clarification requests in English. We will also answer them in English. So if there are two teams that have the same number of solved problems and the same time penalty, is there some tiebreaker in that case? And the answer is yes. There is a third tiebreaker, which is the time of the last correct submission, or in other words, the team that first reached that score is the one that's ranked higher in the scoreboard. So will the questions tomorrow also have names that start with A, B, C, and so forth? And yes, that will be the case tomorrow as well. So if you have a wrong submission that fails on the first test case, that is like one of these sample test cases, does that give a time penalty? And the answer is yes. These test cases aren't treated any differently. So this will result in a time penalty. So how do submission tokens work? So if you submit a lot of submissions in a short period of time, you might have gotten an error saying that you're out of submission tokens. And the way that this works is that Caris looks at the number of submissions that you made in the past 15 minutes. And if you already submitted 15 submissions in the last 15 minutes, you'll have to wait a little bit until that is no longer the case. So yeah, you cannot submit more than 15 submissions in any period of 15 minutes. Are we allowed to use multi-threading in our code? The answer is yes. But the way this works is that the judge actually accounts the total amount of CPU time that you use. So you should only be able to spend, if you have 2 cores, then you'll only be able to spend half of the time in one of the cores and half of the time in the other core. So you're allowed to do that, but it shouldn't help you anything at all. Okay, so yeah, I think we can open for questions from chat. If there's anything on your mind that you didn't see answered here or didn't get an answer during the practice session, we'll now give you some time to send that over chat. A question here is, why was the time limit for B so high? I'm not sure I have a good answer for that. So we try to be generous in our time limits. We try to make sure that Python solutions also run in time. Another question is, do we get a penalty time if the submission fails to compile? That's a very good question, and I think the answer is no. I don't think you get time penalty for compilation errors. Let me get back to you on that, but I'm pretty sure that you don't get time penalty for compile errors. Okay, any final questions? Okay, I think I'm not seeing any more questions in chat. Jeroen, do you want to give language statistics?
Yeah, I'm not sure if there's much to say about this. So C++ was the most popular language, followed by Python. And it seems that C, Java, and Kotlin are less popular.
Cool. All right. So next up, we're gonna resolve the submissions from the last half an hour during this contest. I'm gonna have to run over to our studio set, so I will see you there. All right. Hello, I'm back. Yes, so let me tell you about this. So if you didn't notice, the submissions in the last half an hour during the practice session, they actually weren't shown, or their results, like their verdicts weren't shown on the scoreboard during this last hour. We call this like the scoreboard freeze. So what we do now is we use a tool called the resolver to look at this last half an hour of submissions. And going from the bottom of the scoreboard, we go up and incrementally resolve these frozen submissions to see what judgment they got. And then resolve the scoreboard and find out which teams are the top teams. One thing to note is that in tomorrow's contest, it'll actually be a 1 hour freeze. So the last hour of the contest will be frozen. Okay, so we can continue from here. So first off, we're gonna go through, have a quick overview of the status of the scoreboard. This is half an hour before the end of the contest, with green submissions being accepted, red submissions being incorrect, and the yellow ones being the ones that are pending, that are still frozen. So I'd like to get some interactivity into the chat. So what we do is every time we have a submission that is pending, what we do is so what we do is every time it resolves to an accepted submission, what we do is we say woo. Every time it turns out to fail, we say ah. So this is a tradition at NWERC, and we're going to keep up the tradition despite not doing this in person. So if you're all with me, I'd like to ask you to do in chat an ah, and then it's the other way around, a woo, and then an ah. So yeah, everyone spam that in chat, and then we'll go through this and see how this works out. Okay, so this is a little bit fast. Yeah, so we have the first pending submission from No Hope that was accepted, so woo! Noobness Limerick Seated got an accepted, woohoo! So Hip Hip from Nottingham got an accepted submission. Williams Tech accepted. A race condition, didn't get accepted. Death penalty, pseudo solve, can you slow it down a little bit? Bicausal, they have accepted. The C team accepted. Amazon is on fire. The Searles accepted. A few teams that don't have any pending submissions. No Hope, Vilnius Tech, Death Penalty, Lost Patrons, Les Searles, Noobness Limited Exceeded. They have an accepted solution. Woohoo! Segmentation truth, they fail. Ah. Flaming potatoes, hip hip, C#, syntax terror, they fail. Snack underflow, drop table teams, brain half the brain. Wow, that's okay. The floor is made of Java. Accepted. Woohoo! Make sure you're typing this in chat. So, Trinity Tourists, we stop here because Trinity Tourists are the Irish champions of the practice session. So, congratulations. Okay, we continue, and Quantum Pigeons, no pending submissions. Rindelerne from DTU, they get accepted. Woohoo! Non-measurables, FIP5 engineers, 2Python, KDU, deep freezing potatoes from Reykjavik University. We stop here because they are the Icelandic champions of the practice session. Congratulations. Okay, so Strustruppernet, FFT, out of touch with the pending submission, that is accepted. Woohoo! The Turbofish, remoted, accepted. Woohoo! Hexaflexicons failed. Snackmentation fault, fail. Fulminant, piece of cake. Okay, we stop here because Dogecoin miners are the winners or the Norwegian champions of the practice session. Congratulations. Fantastic, accepted. Woohoo! Ice, Team Dream, Julerianen, accepted. Woohoo! Ballonderene, fail. Turn 42, accepted. Congratulations. Okay, so SP3D, stop here because SP3D are the Estonian champions of the practice session. Well done. Okay, algorithm speed, Radoslav Dimitrov, fully Vilnius Tech, Nubenus Limit exceeded, remoted, Rindlerne. Okay, we stop here again. So Rindlerne are the Danish champions. Well done of the practice session. We need to qualify this. This is only the practice session results. Turn 42, out of touch, insert kebab, Perry the C++, Ballonistics, Ularnian, Lord Voldemort, Dolores Tumbrits. We stop here because Dolores Tumbrits is the first team to solve problem C. Well done, congratulations. Segfault Gober, CPU Mons. Stop here because CPU Mons are the Belgian champions of the practice session. Well done. Baltuslav, Polish, I don't even know. Lots of square brackets. We stop here because they are a bronze medal winner in the practice session. Well done. German Center for Platernipus. They are also bronze medal winners in the practice session. Well done. Duck Giraffe from Utrecht, bronze medal winners with 3 problems solved. Well done. Hope Passes, Vilnius University, bronze medal winners with 3 problems solved. Well done. Wild Falls, Break, Utrecht University, silver medal winner. Congratulations. Easy Peasy, 3 problems solved, silver medal winners. Well done. So it's very not interesting, these top few places here. Hopefully it'll be more interesting tomorrow. So hookup table, silver medal winners in the practice session. Well done. Team 47 again, from Glasgow University. Silver medal winner. Well done. Owl, gold medal winner. 3 problems solved. Well done. Sin City from University of Helsinki, gold medal winner in the practice session. Awesome, well done. Congratulations. Let's Party, Home Alone, another gold medal winner. 3 problems solved. Well done. Cyan Forces from KTH, our gold medalist, our champions actually of the practice sessions, the first to solve problems A and B, and our overall winners of the practice session. Awesome. Okay, so that's it for the Resolver. I hope you had fun taking part in this. I hope you spammed in chat woos and ahs. So this is how it'll go tomorrow when we run the Resolver on the main contest. Yeah, so this is it for kind of the main part of the schedule today. If you don't come back until tomorrow, I just wanted to make sure that you remember that many of the countries in the NWERC region will be switching over to daylight savings tomorrow. We picked the best possible weekend to hold this contest. But yeah, tomorrow morning, make sure that you know when the contest starts in your time zone. So if you go to the NWERC webpage and to the schedule, click on the competition tomorrow and check when the contest starts in your time zone. I think that's it for now. So what we have for the remainder of today's live stream is presentations from our valuable sponsors. Yes, I think that's it. I will hand it over to them, and we'll see you tomorrow.
The PTs as part of the Huawei Open Source Technology Center, OSTC. So who are we? What do we do? Why do we do it? Oh, and how do I poke an email to you? Here you go. We are a team focusing on open source projects, in particular Open Harmony OS. We all come from various areas of expertise, from firmware, kernel, all the way up to the rainy clouds. But we are all connected by an open source culture with experience in well-established open source projects like Linux, Zephyr, Yocto, to name a few. So we came together and started to build Open Harmony, an open source project which targets a all-scenario intelligent ecosystem. Say what? Basically, we work on a product baseline that is vendor lock-in free. No matter the device, you can adopt the project using the same unified user experience, and is completely done openly and transparently. That probably sounded a bit soft, and I know you are the kind of people who like to tinker with things. So, digging a bit deeper into the architecture, I would say that it allows you to plug in different kernels, Linux, Zephyr, etc. On top of which, we use a common user space base system. That, along with using Yocto as build system, would probably resonate with your experience and general open source exposure. What we do is bring that into an ecosystem that works in a unified manner. And not only that, on top of those layers, we have what we call a distributed virtual framework. Just imagine that you wouldn't be limited by the resources on your device. You would be able to use a pool of resources that you have in your house and use those resources by the application in a transparent way. In other words, various devices can form a resource pool and expose an API that applications can use. If that caught your attention, you will be interested in checking things out. Get involved or contact. As I already said, everything is public. So you already have access to code repositories, developer guides, and even have a platform to chat with us. But let me show you. Our home is a GitLab instance. You will find in the wiki a 4-step guide on how to use things around. You can download the software, you can use it, and you can hook your own components, your own software stacks to it. You can get information about the supported boards and how to build for those boards. You can find information about the documentation, you can find information about how to contribute to our code and our documentation. This is our project wiki. You also have a sub-project that is Open Harmony OS specific and will provide you with all the internals of the platform, the components, the build system layers, and so on and so forth. So, why would I get involved? 5 points. Code is open source, inspectable and peer-reviewed. Multiple eyes guide the quality of the code. We provide governance that is transparent and includes multiple parties. flexibility in features, suppliers, and roadmap choices. In other words, technology freedom. It's economic, as it combines efforts and investments in between multiple parties. And least but not last, it recognizes you, the individual developer, access to a shared learning stage, and become an opportunities hub. There you have it. For those of you not bored with my technical bits, you will find Hibo interesting. Without further ado, I'll pass it to Alexander.
Hello, I'm Alexander, and today I'll present Hibo, a submission that won the NWERC's 2020 Black Box Optimization Challenge. To set the scene, our goal is to maximize a black box function by finding a probably mixed variable x. Such a setting is widespread, with ubiquitous applications ranging from molecular design to neural search and AutoML. One way in solving this problem is to follow a Bayesian optimization scheme that executes the following 3 steps. In the first step, a surrogate model, usually a Gaussian process, is fit. With that acquired, the second maximizes an acquisition to determine new search points. The third then evaluates new inputs by querying the black box, and the above process repeats. During the surrogate fitting, one typically assumes a Gaussian likelihood in the GP model. Unfortunately, across the competition data, noises can be highly complex, leading us to realize the first problem of non-Gaussian likelihoods. Apart from the likelihood assumption, we realize a second problem related to the choice of acquisition functions. We know there are different types of acquisition functions, EI, PI, and LCB. They all have a shared goal to help determine which points to next evaluate in the black box function, differing in how they trade off maximizing expected return with uncertainty-driven exploration. However, it is not clear which one works best in general, an important problem when applying BO to a wide variety of tasks, such as in this competition. Now, let us understand how we dealt with non-Gaussian likelihoods in Bayesian optimization. We use a learned nonlinear transformation on the input and a fixed nonlinear transformation on the output to better deal with non-Gaussian likelihoods. We use a warped Gaussian process on the input. Specifically, we use the CDF of the Kumar-Aswamy distribution, a bijective transformation that remains between 0 and 1, and importantly, only introduces 2 additional parameters, A and B, per input variable, as shown in the equation in the top left. Additionally, we apply a power law transformation on the output variables, as shown in the equation at the bottom left. This transformation reshapes the target data to better resemble a Gaussian distribution, as shown in the plots in the bottom right. Having dealt with problem 1, we can now detail how we tackled the second. What acquisition function do we use and how do we optimize it? Why pick one acquisition when you can hedge your bets and pick multiple? We use a multi-objective acquisition function instead. As shown in the plots at the top right, each individual acquisition has a differing maxima point. By finding a Pareto set between these acquisitions, produce a diverse and informative set of points to be evaluated next in our black box function. But how do we find this Pareto set? We use a multi-objective evolutionary method, NSGA2, to find a Pareto set. Importantly, this method supports mixed variable mutations and crossovers, further customizing Hibo to the competition data. Apart from the above, we also realized very interesting properties in the data. Please focus on the left plot. When conducting offline dataset analysis, we observed correlation between a regularization parameter C and model accuracy up to a certain region. Zooming into this region, on the right-hand plot, we see no clear correlation. We conclude that the best method to search would appear to be random. Thus, we wanted to design a method which was able to perform coarse search up to a promising region and then fine-grained random search within this region. This led us to creating a novel robustness technique, which allows our Bayesian optimization algorithm to resort to random search when the learned likelihood noise is high. This is achieved through adding on a noise dependent on the likelihood variance onto the posterior mean of the Gaussian process. As you can see in the plots, as likelihood noise level increases, we similarly get increasingly random search around the desired region. All additional components are shown with their corresponding rating as to how effective this improvement was. Overall, these components constitute HEBO, our submission that won this NWERC competition. Thank you very much for listening, and good luck with the competition.
An ICPC gold medalist and Kotlin enthusiast. In this short video, I will be using Kotlin to solve a sample algorithmic problem that appears sometimes on coding interviews. This problem will concern finding dictionary words inside the rectangle filled with letters. Let's go to an IntelliJ IDEA window to discuss the problem and solve it in Kotlin. First of all, I'd like to thank Solontus_ and Lalit Kundu for bringing up this problem on different websites. So the problem is we have a rectangle filled with English letters and a set of words that we will call dictionary. And the question is, which of these words can be read in this rectangle if we are allowed to read horizontally or vertically and turn 90 degrees as many times as we want. For example, in this rectangle, we can read the word Kotlin or fun or file according to these rules. Let's hard code the rectangle with letters into our program. So this will be a row string with all these tabs and line feeds that we will deal with later. And the dictionary will be also stored as a row string that needs some processing as well. The rectangle row string has all these tabs and line feeds, so let's first remove the tabs by trimming all the indentation of the string. And now we have a single string with letters and line feeds, so let's split the string with a line feed character to receive not a single string, but a list of strings that are horizontal lines of the original rectangle. We can print the resulting variable to make sure we got our trimming right. And now for the dictionary line, let's make sure it's uppercase, just as all the letters in the original rectangle. And now with this uppercase single string, we can split it by a comma and a space to receive the list of single words of the dictionary. Actually, knowing that I want a lookup operation in this data structure to be quick, I can make this a set. Now let's actually code the method that is going to do the main work. I propose a recursive implementation over here, so let's discuss the signature of our method. For now, let it receive the coordinates of the cell that it is currently processing, but we will update the signature with some more arguments later. When we enter an instance of this recursive method, we are standing in the cell with coordinates x and y, and in general case, we want to make a recursive call into each of the 4 neighbors of this cell. How do we organize the iteration over all 4 neighbors of this cell? Well, I propose a list of vectors that show the directions towards all the 4 possible neighbors. In this list, I will be using Kotlin pairs to store the direction vectors. Now, in the recursive call, I can iterate over all the possible shift vectors, and in this for loop, I will be using multiple variable assignment to introduce 2 variables, the x shift towards the new neighbor and the y shift. With these 2 variables, I can calculate the coordinates of the next cell that I will visit in the upcoming recursive call. We have the new x coordinate and the new y coordinate, but these 2 coordinates can show outside the rectangle, in which case I want to ignore this iteration of the for loop, as this shift vector is useless. Also, I definitely want to know the letter that is located in these new coordinates if they indeed show inside the rectangle. So let me write the code that does these 2 things simultaneously. I could have written a simple code that makes a direct access to the 2-dimensional array by the y coordinate and then by the x coordinate. But this code raises an exception in case a y coordinate or an x coordinate goes outside the rectangle. So let me rather use nullable objects here that Kotlin handles so nicely. And instead of taking the horizontal line with such index, I will rather use the getAllNull method that will give me the horizontal line with such index or null in case this index is invalid. For this object, I want to do something only if this object is not null. So I put a question mark here, and then I apply the same method to receive the value in the certain index or null if this index is invalid. This object is the letter located in the desired coordinates or null if at any point the y coordinate or the x coordinate was pointing outside the rectangle, in which case I want to disregard the entire iteration of the for loop, which is exactly what a continue operator does. So if I have reached this point of code, then I didn't run the continue operator, and therefore my coordinates are showing to the actual cell and not outside the rectangle. So I can make a recursive call to these new coordinates. So over here I make a recursive call to the new cell that I'm sure is not a place outside the rectangle. However, this resulting code is an awful example of the infinite recursion, because each instance of my method always runs several other instances of the same method for the neighboring cells, and they do the same recursively, and so on and so on and so on. So we need to stop our recursion at some condition. In order to do this, let's change the signature of our method so that it receives the word that has been already read during the previous recursive calls. With this word, we can stop the recursion if this word is not a prefix of any word in the dictionary. We need to pre-calculate before the recursion the set of all the prefixes of all the words in the dictionary. Let's take our dictionary, and I could have used the map method to receive the list of lists of all the prefixes of the words in the dictionary. But what I actually need is the concatenation of such lists. So instead of the map method, I will use the flat map method that will do exactly the thing. Inside this flat map method, I want to receive the collection of all the prefixes of the given word. So let me introduce the word variable that I will be working with. And here I need to construct a collection with its prefixes. It will be a list, and the length of this list will be the length of my word plus 1. And for each index, I want to generate the prefix of my word with the corresponding length. So from my word, I take the corresponding number of letters. And once again, since I want the lookup operation to work quickly, this overall collection should be rather taken as a set, not a list. Now let's get back to the recursive method. In case the already read word is not a prefix of any valid word in the dictionary, just disregard the entire recursive call. And if the current read word is exactly a word from the dictionary, let's print it to the answer. And the recursive call to the neighboring cell should also pass the correct argument to the method. So it will be the already read word plus the letter that we have seen in the new cell. Now we are ready to make a call of the recursive method for each cell of the rectangle. In order to do this, we iterate over all the possible values of y coordinate, and instead of writing the specific lower and upper bounds, I'd rather write the indices of the rectangle, because this is exactly the values for y that I want to iterate over, and I will not make a mistake by +1 or -1 in such code. Now, for the x coordinate, let me also write some code that will be safe from +1 or -1 mistakes. So these are the indices of the horizontal line, for example, number 0. And for each y and for each x, I make a call to the method search with these two coordinates, and the word that I start with is the word consisting of a single letter in these coordinates, passed as a string. These for loops will run the recursive search from each starting point, and these recursive searches will print all the found words to the output. So let's run this code to find all the words in our rectangle, and we see that our rectangle contains all the words from the dictionary except for the word null. The basic problem is solved, but the important exercise yet to be done is to forbid ourselves from coming to the same cell several times, because it's a very natural thing to disallow, and our code still allows such behavior. So I leave it as an exercise for you, or probably we will do this in some other later video. Thank you for watching this video. Have fun using Kotlin and other programming languages, and good luck in your careers. Bye.
Okay.
So welcome everyone. My role over my job over the next few minutes will be to give you a very short introduction to possibilities for master studies at our department, the Department of Computer Science at Reykjavik University. In fact, my goal and my not so subliminal message will be in three parts. First of all, I will convince you that thou shalt study at master level in computer science. That would be a great investment for your future in case you need any convincing at all. Second, I will convince you that you should do so with us at Reykjavik University. And finally, as icing on the cake, I will also have a look at my crystal ball and try to estimate what kind of impact your decision of studying with us may have on your future. So let's fasten our seatbelts and let's start our journey through Master Studies at the Department of Computer Science at Reykjavik University. Let me put the decision you're about to make into a larger context. We are living in uncertain times. It looks like it's very difficult to even try to fathom what may happen tomorrow, let alone a few years from down the road from now. However, at the end of the day, this is nothing new. We are facing uncertainty in every day of our lives, and we make decisions whose impact on the future in our professional life or even in our life in general are difficult to understand at this moment in time. In fact, as Pete Hine and Niels Bohr famously said, prediction is very difficult, especially about the future. So what is it that you can do in order to tame this uncertainty and to make the right decisions, or decisions that have a good probability of being right for your future life? Well, here's another quote from a famous computer science pioneer, Alan Kay, the guy who gave us the graphical user interface and one of the early object-oriented programming languages, namely Smalltalk. He went on record as saying that the best way to predict the future is to invent it. Now you may ask yourself, why does it matter for me at this moment in time? Well, it actually does, because embarking in a master degree is going to give you the tools and the frame of mind to invent the future for all of us. And of course, you're part of the global future, and we will play a leading role in shaping it. And if Alan Kay was right, that's the best way to tame uncertainty and to make sure that you will be part of the solution to the problems that future society and yourselves will have to address, rather than being part of the problem. So how is pursuing a master degree in computer science allow you to invent the future? Well, let me sort of put it this way. By pursuing a degree in a computer science degree, you will go from brown to red belt in the martial arts of computational problem solving. You can then go on to the black belt, but for that you will need a PhD degree and further education down the road. However, going from brown to red belt already means that you will go from knowing the fundamentals of your favorite subject within computer science, which is what a bachelor degree gives us, to develop depth and mastery. That's where the master word comes in computer science, in a master degree. You will develop depth and mastery in some specific subjects in computer science. How will you do so? You will do so by taking advanced courses in specific topics in computer science which are of interest to you, but even more so by inventing new knowledge, by having and developing some research experience that will hone your creativity and your ability to keep learning throughout the rest of your professional careers. Because it's absolutely clear, and it's been for a long time now, that in computer science, we really do not know what the field will be like 5 years from now, or perhaps even tomorrow. The field moves so fast, and it has so much impact in our everyday life, that the only way to ride the wave and to become employable, in whatever job you may want to pursue, is to improve and to learn something new throughout the rest of your lives. And being able to do research is a way of generating new knowledge and to keep challenging yourselves. So there is no best way to hone your creativity. More prosaically, with a master degree, you will have increased career options. Of course, a bachelor degree in computer science or in related topics gives you an amazing array of career options. However, if you want to go above the entry level, if you want to lead developments rather than being led by them, a master degree is of great help. And it usually comes with some perks, typically high salaries in whatever jobs you might take, stable job growth, because people with master's degrees tend to be given higher, better responsibilities in whatever job they may have. And if you're interested in further studies, it's a necessary condition in many countries to be admitted to doctoral study opportunities. So that's why you should do it. On the picture, you see Pandora opening her box. Now, in the Greek myth, when Pandora opens Pandora's box, it's all the nasty stuff that comes out and only hope is left behind at the end in the box, or hope is the last thing to come out of the box. In your case, the plethora of things that will come out of your box when you open it, if you have a master degree, are only good things. No bad ones will be there. A plethora of opportunities. And this plethora of opportunities that will be open to you is not just limited to opportunities in Iceland, because the world is a computer scientist's oyster, especially if you have at least a master degree. Computer scientists work everywhere. Many of our students, they are employed at the companies whose products you use every day, from Spotify to Google to Facebook, you name it, and they work all over the world. Moreover, you can work even for an Icelandic company somewhere else. If you fancy a warmer climate, you can work there and work for an Icelandic company. Because a computer scientist's job is very often something you can do wherever there is an internet connection, possibly on a beach on a Caribbean island, if you like to do so. And if you're good enough so that somebody can give you the job, that job opportunity. And if you have a master degree, you're more likely to be given that type of job opportunity. So I hope I've convinced you that thou shalt study for a master degree in computer science. Let me convince you now that you should do it with us at Reykjavik University. Well, first of all, the Department of Computer Science at Reykjavik University is the largest, but size really doesn't matter. What matters is that we are the most research active and international computer science department in Iceland. At my latest count, there are at least 16 nationalities that are represented within our department. And we have a large cooperation network because we are research active. Now you may say, why does this diversity matter? Well, it does matter because a diverse research environment gives you the opportunity of experiencing a variety of viewpoints that will enrich your computer science culture, and in fact, your culture in general, so that you can develop as many tools as possible, as many ways of handling problems as possible in a variety of settings. Moreover, our large cooperation network will allow you to connect to researchers and computer scientists, practitioners all over the world. I'm happy that a significant, by computer science standards at least, percentage of our professors, PhD students, and master students are women. Of course, we want to do more. So if there are ladies out there who want to study with us, join us. You will not be alone. And we need you because we need your viewpoints and your contributions to our field. So what kind of master programs do we have? Well, even though our department is relatively small by any standards, actually it is small by any standards, we offer a variety of master programs. In fact, sort of spanning a typical master degree in computer science, going on to software engineering, which specializes on tools and techniques for developing the large software systems that sort of make our society thrive and function. We have a master program in artificial intelligence and language technology, where you will learn how to use the tools of computer science and artificial intelligence to the analysis of language. Speech to text, language understanding, automatic translation, you name it. And the people behind this program are those that allow your digital devices to understand Icelandic so that you can communicate with Google, say, using your own language, and that sort of power the automated speech to text translation of everything that goes on in Althingi today. The new kids on the block are two master programs in data science, and I'm pretty sure that I don't need to tell you that data is the new oil. Data is the most valuable resource, raw resource that we have today. Very often it's abused, but it can be used both for good purposes and to create business opportunities by people who take a master degree in data science. There are two options. There is a master degree in data science, which is a classic 120 ECTS full-time study program. And there is a master in applied data science, which can be taken with work, and it's a 90 ECTS program. The master degrees in data science, both of them are offered in cooperation with MITx, and several of the courses that we offer in the study programs are delivered by MIT. As I mentioned before, we are an international department, internationally well connected, so we actually take part in master degree programs with foreign universities. For many years, we've had a double master degree program in computer science with the University of Camerino in Italy. It's a small town, Camerino. It's an old university town in a beautiful location. And we often get many students from Italy studying with us, and some of them then stay on for PhD studies at Reykjavik University, and a small number of our students have gone there to take advantage of Italian food culture and computer science. We are also one of the sites of a Nordic master program in intelligent software systems. The other sites are Mälardalen University in Sweden and the Åbo Academy in Finland. So these are joint master programs. People usually take 1 year at one of the other institutions and one at Reykjavik University. And again, some of the people who come to study with us in that program, then they stay on. There is at least one PhD student at the department today who was a former student in the Nordic Master in Intelligent Software Systems. Another thing that you get from our wide network of connections is that we have a variety of internship agreements, both formal and informal, that allow you to study and conduct your research abroad. So let me start with two examples of our formal internship agreements, one abroad and one in Iceland. We have an agreement with the Fraunhofer Center for Experimental Software Engineering at the University of Maryland, and they take today about 10 students per year from us. At the beginning, we started with 2 students, but they were so happy with the students that we send them that they are willing to take as many as we could possibly send, modulo the fact that How many they take really also depends on the type of projects that they have for our students to work on. And students of ours who've gone there, they worked on projects with the automotive industry, like Mercedes, for instance, BMW, projects in biomedical topics with the Food and Drugs Administration and others, and with NASA. In Iceland, we have an internship agreement with CCP Games. They offer a small number of internship positions to our students. And then again, what happens is that they hire our students, sometimes even before they actually finish their studies. And both the internship agreements with Fraunhofer and CCP Games, they're actually paid. Let me give you instead a glimpse of another possible internship option that we offer. This one is not formal, but we have strong ties with the prime movers behind this project. I don't know if you've ever heard about the Software Heritage Project. That's a joint project run by NWERC, which is the French National Center for Computer Science, and UNESCO, the United Nations organization. And the goal of the Software Heritage Project is to create the version of a modern version of the Library of Alexandria, but for source code. Software is our heritage, just like books are our heritage. So we should preserve software source code for posterity. So the goal of the Software Heritage Project is no less than to build the universal software archive. And to date, our colleagues behind the Software Heritage Project and the students interning with them in France, in Paris, at the NWERC facilities, they have currently archived about 10 billion source files of source code of programs from about 154 million projects. The underlying graph of source files has about 20 billion nodes and 200 billion edges. And this graph is automatically generated, automatically updated every time there is a new commit. And you can imagine how much work, both in terms of manpower and in terms of brain power, is needed in order to develop the algorithms to milk all the software from the internet and milk all the commits and keep the overall archive up to date and available for everyone to see. That's a fantastic opportunity, if you ask me. And I know the director of the project, so you can get in touch with me if you're interested. So I told you that in a master degree, you will hone your skills for lifelong learning by doing research. Now, how do you do this within our department? Well, I'm biased because I'm talking about people who work with me, and I'm currently the chair of the Department of Computer Science. But I can truthfully tell you that by working with people in the Department of Computer Science at Reykjavik University, you will be working with some of the best researchers in their field. And moreover, these researchers organize themselves in active hubs for research, which are our research centers, some of which have been active since 2005, before you were born, well, roughly. So our core research centers are CADIA, that's the Center for the Design and Analysis of Intelligent Agents. In other words, it's our Center for Research in Artificial Intelligence, and it's been active since 2005, April 2005. And I don't think there is any need for me to sell you artificial intelligence. We are currently running a series of webinars on artificial intelligence for the general public. I encourage you to join us for those presentations. There is CRES, that's, if you wish, the Center for the Development of Embedded sort of an engineering of software systems. That's basically everything to do with systems and software engineering. FinTech, that's the Center for Financial Technology. Keywords there are blockchain, smart contracts, all the computer science technology that modernizes and makes freer than it was before all the world of economics. ISTCS is the center that is closest to my heart because it's the Theoretical Computer Science Center, the one I contribute to since April 2005. If you're interested in the mathematical aspects of computer science, algorithms, sort of theory of computation, anything that has to do with programming languages, types, and their semantics, then ISTCS is the center for you. And then there is the Language and Voice Lab, which technically speaking is actually a sub-center of CADIA, but since they ran the master program on artificial intelligence and language technology, I prefer to sort of mention it separately. These are the people who work on keeping Icelandic alive in the digital age using the tools of computer science. So if you think about sort of Google Translate, text-to-speech translation, speech-to-text translation, and all that jazz, that's the center for you. But we don't stop there. Why? Because all science is computer science, and we want computer science to be the hub of research activity in all kinds of fields throughout the university. So it should come as no surprise that we also participate in research activities in biomedical engineering, for instance, in the Medical Technology Center, in the Sleep Institute. In fact, sort of Ertma Siv Arnardottir, who's the leader of the Sleep Revolution project that was recently funded, richly funded by the European Union, is partly employed by the Department of Computer Science, and some of our colleagues play a key role in the sleep revolution research. And also the Sustainability Center, because we want to be part of the solution, not part of the problem. And in order to make the world we live in sustainable, computer science know-how is absolutely vital, because humans cannot be trusted to make the right decision from the amount of data that needs to be analyzed in order to make the right decisions for our environment. Of course, we are in the loop. We are a component, and we need to make decisions, but we need support, decision support, and that's what our machines and algorithms give us. So by working in these research centers, you will be like the happy coffee drinking researcher that you see on the slide. So you will not be frustrated. You will be part of a thriving research environment in which everyone helps everyone else to achieve the best work they are capable of. I've already been singing the praises of my colleagues. You don't have to take my word. Just you can look us up in Google and see what kind of standing we have in our research community. But if you don't want to do that, let me just quote, show you a short piece of text from a report that the Norwegian Research Council commissioned from an independent organization when they looked into what subject areas Norwegian universities should cooperate, would benefit the most from cooperating with international partners, and within those subject areas, with which universities. Now, not surprisingly, information and communication technology was one of the areas that was targeted by in this report, but perhaps more surprisingly, if you look at the institutions in the strategic countries with which Norwegian universities should cooperate, apart from institutions like Georgia Tech, Southampton, the MIT, the Technion in Israel, and several others, you will see Reykjavik University. So we are not doing too bad, I think. So now you may wonder about practicalities. I think this is the most boring slide for me, but it's not boring for you. So how much does it cost to study with us? Well, Austa will correct me if I'm wrong, but sort of our fees are the ones that you see on the slide, 379K per semester if you're doing full-time studies. However, there are some options to get tuition waivers or tuition reductions. So for instance, if you study full-time and you had a good GPA during your bachelor studies, then you only pay bachelor tuition for master studies. That's what we call the Dean's Scholarship. Moreover, you may wonder why Alan Turing is on the slide. We have one Alan Turing Scholarship per semester. So if you are a full-time student and your GPA during your bachelor studies was at least 9, then you pay nothing throughout your master studies. In addition to that, since my colleagues are so good at their research and getting funding for their research, there are plenty of opportunities for being hired as research assistants and being paid as research assistants during your master studies. And you can also work as teaching assistants in courses for which you get paid. So you don't just pay, you can also get paid by us. So I promised you a look at your crystal ball and my crystal ball. Now I'm looking at my crystal ball and I'm looking at your future. And to be completely honest, everything is a little bit murky because perhaps the jobs that you will be doing, the topics that you will be doing research on, they don't exist today. Actually, most likely they don't exist today. However, what I can tell you, and if I look back and I look at what our students did after they took a master's degree with us, so I can tell you that several of them are today software engineers at Google or at other top class corporations. Some others stayed here. That's Nera Nesic. She came from Croatia. She was an exchange student. She did an excellent master's thesis on a topic in AI. And today she has a good job as a software developer at NetApp close to Kringland. So as I've said, my crystal ball is murky, but one thing it is clear on is that you will be like Buzz Lightyear. After a master degree or during a master degree in computer science or related subjects with us, you will be embarking in a journey to infinity and beyond. Where that journey will take you, I do not know, but it's going to be for sure an exciting journey in which you will learn a hell of a lot and you will reinvent yourselves over and over again. So let me reiterate to you the take-home message, the main take-home message from my presentation. I hope I've convinced you that the best way to predict the future is to invent it, and that by taking a master degree in computer science with us, you will become ready to invent the future. And your future, our future, the future of everyone else in society around us. Now, to conclude the talk, with a futuristic approach, let me step into the shoes of my alter ego, Captain Jean-Luc Picard from the SSS Enterprise in Star Trek. You are the future. You will invent the future. Let's invent it together. Make it so. Thank you. And if you have any question, I'll be happy to answer them, assuming I can.
Thank you, Luca. So if there are any questions, that would be great. Maybe Edda should then take over and give us a short presentation on how it is to be a student at RU.
Hi, guys. Can everybody hear me?
Absolutely, Edna. I can hear you.
Okay, great. So I was asked to talk a little bit about my experience of being a student in the master's program at RU. And yeah, there's a lot of good things to say actually about the master's program. You might actually have seen me before in some advertisements for the master's program, and I swear I'm not being paid actually. I really just want to represent the department because it's a really, really fun environment and a great study. So of course, number one is the courses. And the courses are all really interesting and fun. And even though they are more challenging than the bachelor courses, I didn't actually feel that the study itself was more challenging, because you have a better base once you're entering the master's program, having finished the bachelor degree. And since the courses, you take actually fewer courses per semester in the master's program, you can actually put more emphasis on each course, I felt, at least for myself, and than I could in the bachelor program. So I've actually been doing a lot better in the master's than I did in the bachelor. So that's one thing. Also, in regards to the courses, like Luca said, there are like many ways you can take through the studies, but you can also like pick and choose. There are not many required courses if you take just like general computer science, which is something I did. So I could really like cherry pick courses that I wanted to take, and maybe courses that I wasn't able to finish or do when I was doing my bachelor's, like some advanced bachelor courses. So you kind of get to like really make your own path through the studies, and you have such a like free reign of what you want to do. I mean, people are so willing to assist you, and that's also another like great thing, is that the teachers are just in the same area as you are, and the teachers have their offices basically on the other side of the hall, and usually the master students get their own desk. So the teachers are basically just right there, so you can always access the teachers, and that's so helpful. And yeah, I just like to point out, if you have any questions, you can like write them as I'm speaking. There is a chat window. I think you can send chats. So if any questions come up, please just shoot, and I'll try to answer them as I'm going along. Yes, so the courses are great, the teachers are awesome, and also the facility is really good. Like I said, we get our own desk, we get our own area, and it's really kind of funny, because when I was doing my bachelor's, which I did at Reykjavik University as well, I would be attending lectures with like, I don't know, maybe 300 people, and I didn't really like get to know that many people through those 4 years. Like I left the bachelor's program just pretty much knowing the same few people I knew when I started. But in the master's degree, like master's program, it's completely different, because you kind of you come into this area and you don't know anybody, but it's such a close-knit and small community that you kind of like start to get to know everybody around you really fast. So I'm actually finishing the master's program like knowing many more people than I did when I finished my bachelor's, where it's like 300 people. So it's really nice, also because the classes are usually quite small. They're much smaller than in the bachelor's courses. And so you're always kind of interacting with the same people, and there's like just much more closeness in the courses as well, like when you're meeting, and also like when you're like we've been doing, of course, like I don't know what it's called, courses where it's basically on Teams or on some Zoom or something like that, and everybody always has their camera on, and there's like a lively discussion and everything. So I think that's pretty great. That's a really great thing about the master's program. And the facility also has like every type of like machines or technology that you could imagine. Like we have a virtual reality room where you can try and develop virtual reality games, and there are actually many like virtual reality headsets you can use. There are 3D printers you can have access to. I mean, there are so many, like basically everything you would want or need you can get at Reykjavik University. There's like so much stuff you can do basically. And Also, which I find really great, is there's free coffee. So that's pretty good. So you can always get coffee if you're getting tired, and that's just in the master's area. Yes.
Don't forget the cheese. Sorry, there are also some. There's also crisp bread and cheese and butter.
Yeah, there's also free some crackers and stuff, and tea. There's some free stuff to eat, so that's good. You can always have something. And so also something that Luca mentioned earlier is the TA job, the paid TA job. I thought that was amazing. The salary is actually really good. It's just like for somebody that's finished with a master's degree. And it's really nice to take a TA job alongside your classes, because they usually fit into your schedule quite well, the courses that you teach. And then if you're doing something extra, like going over assignments, that's really like you can like do it on your own time. So there's like no really like hard times for a lot of the work you do, even though there are some deadlines, of course. But yeah, you can like choose at which hours you do it in the day or in the week or whatever. So that's really great. So you can actually just pretty much pay up your master study like by working as a TA alongside. And one final thing before I start talking about the RUMPs, which is something I'll get into later, I just want to give a shout out to Ásta, who is there, because she's been such a great help. She's amazing. If you guys need anything, you know, any help, like, I don't know, Ásta has just been, for me, like a guardian angel. She has been sending me like reminders if I forget to sign up for courses or something. So you really feel like people are there to kind of help you and assist you. And yeah, it's really nice. You're not alone. You never feel like you're just on your own in the studies. There's always somebody to kind of back you up. And finally, I want to talk about the félagstarf, the social. Peter is saying something. Okay. So
sorry, I forgot to mute myself. Social life, yeah.
Social life, yeah. The actual. I can't remember what the name of it is, like client, but it's called RUMPS for us. So RUMPS is basically, it stands for Reykjavik University Masters and PhD Students. It's basically just a really cute name, but that's our our félag. And there's actually really, there's always something to do. They've been really great at scheduling some events and stuff. And Pétur, that you see here, he's actually the gjaldkeri of RUMPS.
Treasurer.
Treasurer of RUMPS. I'm missing some of these words here around RUMPS. Yeah, he's the treasurer of RUMPS, and he's actually been like scheduling a lot of the events. And there are a few events that are like, so of course in COVID it's been way more difficult to have meetings. I mean, usually it's been really active. There are of course like vísindaferðir. It has usually been one árshátíð where we meet and do some fun stuff together and eat and drink, and it's a lot of fun. But we also have a bi-weekly game night where we meet up at Reykjavik University, play board games together, and usually there's like free pizza and beer. But in COVID, we actually moved the game nights online, which was also really fun. It was surprisingly fun. And then we just have like a Discord chat, and people are just playing together, and it's kind of, yeah, people are coming and going as they please, and it's really fun. You don't have to pay anything towards RUMPS, actually. It's like free to join. And like, yeah, RUMPS, we do a lot of things. Basically, if you get an idea you can usually pitch it to rumps like, oh, I would love to do this, and it's usually like really well taken. I mean, somebody got the idea to buy a fridge to store the beer, and we just bought a fridge. So you can usually just pretty much get the rumps to plan events and whatever you feel like. And yeah, also when there was Halloween, I don't know, was that rumps, Peter, with the decoration competition?
No, not really.
Oh,
That
it
was
was
Asta mainly.
Asta. I thought that was such a fun idea because when it was Halloween, I think last year, maybe the year before, we had like a decoration competition. So everybody like decorated their desks, and then a committee would choose like the best decorated desk and gave out actually awards. So the whole department was like super decorated before Halloween. And also around Christmas time, everybody like decorates the desks, and it's just a really, really good morale. It's really a lot of fun. It's great people. You're gonna meet so many nice people, and there's people like from all over the world, which is also just always amazing. I mean, it's such a, yeah, it's such a melting pot of culture, basically, just there in this little space. So it's so much fun. So I think I'm done. If you guys have any questions, just please speak up or write into the chat. But otherwise, I'll just say thank you for listening and hope to see you guys.
Thank you so much, Edda and Peter. So, yeah, I don't think we have any questions that I can see, at least. So, should we just look at what you say? Do you have anything more to add?
Yeah, I just want to say that I can confirm that the opinions that Edda and Pieter mentioned, we didn't plant them in them, and we didn't pay them to say what what they said, which I appreciated greatly. But for the record and for financial transparency, the department does give some money to RUMPs to run their activities.
Yeah, yeah. That's why. Well, that's why there's no fee. Yeah.
So, which is sort of a token of our appreciation to the work that RUMPS does to create a good social environment for our master and PhD students. And on the other hand, it also indicates that the department places a lot of emphasis on the social aspect as well as the educational aspect of being a master and PhD student within the department at Reykjavik University. And okay, sort of, there is a question actually from, I remember seeing Háskóla með vinnu, is there any such thing for a master's degree? Now, there are some of our master's degree, like the master degree in applied data science, that is especially designed essentially to be taken with work. There are also possibilities, I believe, Austa, you will correct me since you are the authority on this rather than me, of deciding the speed at which you take the courses in your master studies. However, when it comes to writing your master's thesis, this involves some research work. So that is, I think, a little bit more difficult to do for many people while they are working at the same time. It's not impossible. It's not impossible. It can be done. But we typically recommend that during the thesis period, students sort of focus on their thesis work. And the thesis can be either a 30 ECTS thesis that can also be done in a small group of students, or a 60 ECTS thesis that is individual and has a more substantial research component. Especially if you do one of those theses, well, I mean, it varies from person to person, but sort of personally, I would recommend doing it as your main activity, at least. So there is another question. Are there some courses that students must complete to be eligible for certain master programs? Depending on the, okay, sort of, these are courses that you should take before. Well, we typically admit students with a bachelor degree in computer science, but also related topics, related subjects, or even sometimes unrelated subjects. However, and we evaluate the strength of those applications. In case there are some courses that we feel are missing and that a student should take before starting the master program in earnest, we develop a personalized study plan for that student. And some of the courses that count for the master level number of ECTS can also be advanced bachelor courses, and some of the courses that people take in expanding their education so that they can make the most of our master degrees might be counted towards that ECTS bank of credits. Any more questions? And if I said anything wrong or my answer need to be expanded, then Austa, Telma, Pietur, and Edda should feel free to spank me, metaphorically speaking.
I think we have no more questions for now, at least. So
let me just also add that in case you have questions later on, you're most welcome to contact Austa, Telma, me, and if you have questions about ramps or the social life, then I guess you should get in touch with Pietur and Edda. They know much more about that than I do. And Austa has just posted their email in the chat. There is another question. Is master's diploma a thing?
no, we don't have a master's diploma. We just offer the diploma degree in the bachelor studies.
Yeah. But there are some master programs, like the master program in applied data science, that's 90 ECTS.
Yep.
All the other master's programs that we offer, there are 120 ECTS. And note that the 90 ECTS one is the one that can be taken with work, and it's actually explicitly designed for that purpose.
Exactly.
So if you're working, you want to beef up your data science expertise, that's the one for you. Or that might be one of the ones for you. They are all for you.
Okay, what are the requirements? Yes, it is possible to apply after a bachelor's in business or economics, but then the Research and Graduate Study Council would review your transcript and make a list of courses that you would need to complete alongside your master's courses. Usually the required courses are like programming, data structures, algorithms, some system courses, and yeah, discrete math, for example, could be around 60 credits in total, depending on the business degree.
or the economics degree
or
that you have.
yeah.
So basically, we develop personalized study plans a la carte if we want to use a restaurant type terminology there. And the reason is not so much to put hurdles to sort of to be gatekeepers for our master programs. It's just that we want to make sure that people who enter our master programs, they have the necessary know-how to take full advantage of the master level courses. Because I mean, if you lack some specific computer science, basic computer science knowledge, you will find it difficult to take full advantage or even to do well in several of the courses. If there is experience through work in any of those subjects, that is that taken into account in the decision of a personal path? Austa?
Yes, if, for example, the applicant has been programming a lot, we would maybe not make him do the programming course at RU. So it's evaluated on personal basis for each applicant.
How does the Camerino program work? The Camerino program works as follows. So so basically, I mean, there are many possibilities, but typically what you would do is you take 1 year of the master program, 1 year worth of the master program at Reykjavik University, and the other year at the University of Camerino. Which is which, you decide essentially. And it doesn't have to be 1 year, it could even be sort of 1 year and a half in one place and half a year somewhere else. And you decide which is one place and which is somewhere else. It's really a double degree program, and then afterwards you get 2 degrees, one from Reykjavik University and one from the University of Camerino. So for instance, one option, but it's just one option, is that one takes courses, say at Reykjavik University and works on the master's thesis at the University of Camerino, or the other way around. Typically, the Italian students take the first year of courses in Italy, and then they come to us, they take some further courses and write their thesis with us. But we've also had Italian students doing it the other way, or coming from one semester in between. We are flexible. The Nordic Master Program is a little bit less flexible in that respect. Sort of, you're supposed to spend, there are 3 sites, 1 year in one side and 1 year in at some other site. But there might be other options there as well. So if you want to go to Mälardalen in sunny, I guess, Västerås in Sweden, or to Turku, then you're in business. After all, Finland is supposedly once more the happiest country in the world, with Iceland coming second. Once more. And Denmark coming third. So at this moment in time, I have lived and worked in 2 of the 3 happiest countries in the world. Because the world is our oyster. So let's take it from there. Let's see whether I go to Finland next. I don't know. Any more questions? And Austa has posted more information on the Nordic Master Program.
Yeah, if someone is interested, then it's really good setup there too.
Absolutely. And if you're interested in knowing more about our internship opportunities, again, you can contact us, or I hope that the information on the Fraunhofer internship and on the CCP internship, they are still available on our website, even though the website is supposedly migrating to some other setup at some point soon. So, so basically, look at the information now, or ask for it now before it gets lost. Sort of usually that's this is what happens when websites migrate.
Okay, so thank you all for coming, and please email me if you have any questions.
Thanks for showing up in numbers.
Yep.
Thank you, guys.
Likewise. And thanks to Edda and Pieter for their contribution, and to Austa and Telma for being with us.
Thank you for having us. It was a lot of fun.
Well, likewise. Thanks for all your kind words. Now we have to make them true.
Yeah.
Have a good lunch, if you still need to have it.
See ya.
Bye-bye.
Bye.
Bye.